Okay, so good morning, everybody, and welcome to the first session of what I think is going to be a really exciting day on Brunel Climate Change Symposium. I think I had a look through the abstracts, the submissions this morning. It looks absolutely brilliant. Lots of interesting things going on right the way across the institution. So it looks like being a very exciting and interesting day. So the format is quick 10-minute talks and then a few questions, and then we move on to the next speaker. And we're going to do 4 talks in every hour. But it's not always chaired by me. So I think Trevor's taking over from me, and then I'm back later on in the over lunchtime. So welcome to everybody, and thank you very much all both for taking part, for volunteering to talk, and for engaging in this. I think it's really, obviously, very important agenda. We're doing some great research in this area, and we have a lot to contribute. So I think that's super. So the first speaker is Colin Axon from Mechanical Engineering, who's been working in this area for a good while. And he's going to be talking about energy security and sustainability. What are the risks? And are you going to share your screen, Colin? Lovely. Off you go then.
Thanks, Jeff. So this is work I've been doing in collaboration with Richard Darton at Oxford. Energy security is often thought about not just in government and policy circles, but in the academic research field, in terms of things that are relatively near term rather than the very long term. When government talks of long-term energy security, it's kind of thinking maybe one parliamentary term, maybe 4 or 5 years. Sustainability, we think about intergenerational ideas and what happens over multi-decadal periods. And we thought, and this is our unique contribution, is to think of energy security in terms of sustainability. It's arguable that long-term energy security is indistinguishable from sustainability in the very long term. So what do we mean by energy security? It's not just keeping the lights on, or is there enough gas storage for the coming winter? Perfectly reasonable questions, but those are security of supply questions rather than energy security question. What we noted when thinking about energy security as a sustainability problem was what was missing from sustainability is any explicit consideration of risk. And that's because sustainability tends to be a backward-looking exercise. How have things that are measurable changed, and how might they change in the future? Whereas energy security is subject to all sorts of risks, which may or may not yet have occurred, or if they have occurred, some very extreme risks may be there may only ever have been 1 or 2 examples, and so there is not a good data set. I'm thinking an extreme example being the meltdown of a nuclear reactor. Fortunately, that has not occurred very often. Whereas other low-level risks perhaps are managed on a day-by-day or yearly basis by companies and governments and individuals. So what we've tried to do is to incorporate risk to what we're really trying to get at is how can you think about how the risk profile or the quote content unquote of risk in a portfolio might be in the future, because I'll show you at the end that it's not necessarily obvious. So we're going to use this method called the process analysis method. I won't trouble you with the details of that today, but you can look that up. But it's been used for a number of different examples, from environment to transport, to do with medicine. It's a robust method and it's transparent, which is the key point. So what we did was break down the fuel supply chains, of which we identified 25. They're not all equally common, and they're not all equally applicable to every nation. So the UK, it turns out, of these 25, only 19 are actually relevant. But we broke the process down into separate stages, and 2 stages would be too few, 3 would be too few, 10 would be too many. Something like 5 or 6 is a manageable number. So you can see that there's some level of aggregation which you lose detail, but it brings it to be tractable. And here's just a small number of examples of both fossil and renewables. And you can see that some stage, say for example in a wind turbine, when you exploit the fuel, you condition the fuel and you convert it. It's all done in one single object, the turbine itself. And that's the output of that is injected into an electricity network. Whereas for gas, you've got to drill for it, you've got to extract it from the Earth's crust, you've got to process it in some quite complicated chemical processing, which we'll come back to, and then you might do different things with it. You might burn it straight away to produce electricity, you might supply it to homes or businesses to use for whatever processes or heating that they want. And you can break down all of the fuels into these sorts of stages, and it gives you a basis on which to start thinking about what are the risks, and where might they occur within each of these stages. And you can then look at start to identify perhaps where the bottlenecks are. So this was an utterly massive undertaking. So I'll come back, I'll show you what the risks are in a minute, but the process analysis method yielded 34 risks in 7 categories. And you look at each of these 34 risks for every single stage, for every single fuel. And if you were to do all 25, you end up with an enormous number of decisions that need data or other literature to support, or perhaps you can only make a judgment based on expert opinion. So what we've done is use a risk matrix approach, and so we're using likelihood and impact to come up with some sort of risk score. And we've used a 3x4 matrix. There are reasons for making it non-square, but and that means you've got a relatively small number of categories, which reduces the likelihood of errors creeping in. And that's another important point, because it makes it much more useful as a tool, as a technique. So what does the risk matrix, when handle is turned, what does it look like? Well, it's taking these different, I picked just one stage 2, the exploitation stage, that's extracting the fuel source from the ground or from wherever it comes from. And what I want you to take away, and these are just some of the risks, and they are posed in terms of the lack of something. So the lack of access to capital, the lack of enough trained specialists or trained people, or insufficient. The risk is there is insufficient rate of infrastructure construction. That's how it might manifest itself. One of the things that's notable is the environment itself poses risks, such as difficult physical access to the resource, maybe lack of water availability in some particular area or particular country or region, and perhaps the quality of the fuel. That is a risk the environment poses to the system, whereas technical risks such as pollution come a result of the technical process itself, and that's posed to the environment. By the way, we treat CO2 as a pollutant. What you can do, don't worry about the numbers, but what this shows is that any particular risk is not the same for every fuel. It's high for some fuels, low for other fuels. Likewise, for any particular fuel, not all, say take gas, which is obviously a fossil fuel, not all of the risks are high level risks. Some of them are very low level risks, they're minimal. And likewise for, say, wind, not all of the risks are low. There are more low risks than high risks, but nonetheless, there are some high level risks. And this is something which is not properly appreciated and is what is probably our unique contribution to this. So understanding the distribution of risks across a supply chain appears to be yield some new and useful information we might be able to do something with. So what's the riskiest fuel? Let's cut to the chase here. Unconventional gas, by which we mean shale gas, is the riskiest fuel. And we'd come up with this list actually a little bit before the government pulled the plug on the shale gas program in the UK for various reasons. So that turned out to be the highest risk. Clearly at the top here, you can see there's some fossils, there's nuclear fission, but also we seem to have some renewables that have quite high level risk profiles. Geothermal energy, it's minimal in the UK, but it's not zero. And that's actually a very high risk, which in part goes to explain why we've not really exploited it, even though we have the resources in the UK. The bio routes appear higher than you might expect, or certainly bio researchers expect. It's not surprising that wind and solar and its variants are down the bottom. But interestingly, I've used what I've termed a nega fuel, as in you've heard of a negawatt, a negative watt, but I've termed fuel energy efficiency and demand reduction as a negative fuel. It was the only way to incorporate it in this structure. And energy efficiency is talked of as the first fuel. That's what my energy efficiency chums will say, and that's what how they think about it. But it's not. If you think about demand reduction and behavior change from a risk perspective, it carries not a huge amount of risk, but it carries more risk than simply creating more supply. And empirically, we've seen that doing demand reduction appears to be way more difficult than most people think. And we suggest that thinking about risk explains why that is the case.
Colin, do you just want to summarize now?
Yep. Okay, so you can see that they cluster a bit. So you can see that the risks that we came up with, all 34, the different categories are spread through these are ranked in order of most risky to least risky. You can see that the different categories are spread fairly evenly through, which is good from the point of view of the process. When we did a workshop with experts, they identified changing policy and regulatory framework as their most important one, and you can see that's quite high up in the list. So we think we've got something that's worthwhile. So what do you actually do with those scores in the end? Well, you can look at future energy portfolios, and I've taken the UKIRK scenarios and applied it to their portfolio, and the black dots are business as usual, the reference scenario, with however the government thinks things might change. That changed yesterday, but let's not worry about that. But a future low carbon scenario, yes, the risk drops, but it starts increasing again. And this is, if you ask a low carbon researcher, they'll say, no, the risk always goes down. It doesn't. This actually comes about because nuclear is coming online or projected to come online in the mid-2030s, and that's a high-risk fuel source. So there's a couple of papers which I encourage you to go and have a look at. We've had published recently, but we think we're onto something here, and if anyone wants to have a discussion with me at any point, so give me a call.
So does it help us to sort of understand sort of broad ideas about mitigation strategies that perhaps cover ranges of sort of energy supply chains? Sorry, just to get in first with the first question.
Yes, in the sense that it's looking across all of the requirements. So not just
you're able to group them together.
Yes, and it's the fact that it's a balanced, transparent approach that so the Extinction Rebellion folk would not be very happy with the economic analysis that's in here, but tough. Yeah, you have to consider that. Brundtland's original 3 pillars of sustainability, economic, human, social, and environmental together equally, and that's why we've got a balanced list here.
Okay. Right, thank you very much, Colin. I'll try and pick up some questions at the end if we've got any time left in our hour. If anybody wants to ask a question, pop it in the chat and we'll let Colin answer it in the chat, and that'll be instructive for everybody. So we'll move on to the next speaker. Thanks, Colin, that's super, great start. Is Simon Roberts, who is also in mechanical engineering, and he's talking about, is the service industry really low carbon? Simon.
The service industry is perceived as a low carbon since services are weightless. They're not delivered by truck, but I think that's something that needs examination, and that's what I'm going to do. Just get my, there we go. This is a graphic that's an overview of the whole subject I'm going to talk about. The circle there represents the service industry, the whole multitude of services, which I'm going to list later. And the key thing, first of all, to draw attention is the employment that the service industry provides. On the left, therefore, we've got jobs as an input. On the right are other inputs, and the top right one is fuel. Now, the emissions of the service industry generally referred to as only to buildings. And when it's just buildings, it's only about 5% of total emissions. But this approach considers the whole footprint. So the other inputs on the right, the second one down is electricity, the third one is goods, and the bottom one is construction of the buildings which they're in. And each of those on the right gives rise to emissions. Staying with the jobs for the moment, this graphic is looking at the service industry in terms of jobs. And on the right, you can see what the service industry actually consists of. So at the top is retail and wholesale, transport and so on. There's a dozen down there. Education is near the bottom. It's quite a broad range. Interesting to look at the period since 1990 that all the...
So, Manoj, are you ready to take over? And we'll see if we can slot Simon in later.
Yeah, perfect.
You want to share your screen there, Manoj?
Yes,
so
surely.
It's a very casual title you have here, Manoj. Food, plastic and climate, how they interplay. How about that interplay? Right, go on, off you go.
So, thank you very much, Professor Rogers, for giving me the opportunity, and thanks, Tom, for organizing such a mammoth task. Thank you. So I'm Manoj Dora from Brunel Business School, and I'll be speaking today about how the food, plastic, and climate they interplay. So let's very quickly let's start. So we are a small family of 3 people, me, my wife, and my son, and we do every week grocery. Yeah, and this is my recent grocery from Tesco, and I took a 30-second clip which I would like to share with you. So this is the amount of grocery plastics we acquired every week in a small family in the UK. Just take a moment to think, every family more or less getting this much of plastic every single week. And there was a recent study actually which found out the 10 largest supermarkets in the UK, they, in combination, 900,000 tons of plastic they push to the households every single day, every single year. So that means, it is almost the weight of 10 Eiffel Tower of weight of plastic. And the same thing, there's another very interesting, figure. Look at every single month, 40 billion bottles of plastics we kind of throw away, which dwarf several Eiffel Towers. So this is one side of the story, the plastic. The other side of the story, look at this. This is the amount of food waste. Every single month, the amount of food waste we generate actually can dwarf the tallest building in the world, the Burj Khalifa in Dubai. So there is one side we see piles of plastic, the other side piles of food waste. Both had serious environmental consequences that we are all aware of. So which one of this is less evil, the plastic or food waste? What do you think? Let's take this example of these cucumbers wrapped in a plastic bag. What do you think? This is necessary or unnecessary? Take a moment to think, necessary or unnecessary. Now let's get to some of the facts. Often food supply chain is quite long supply chain, food coming from all different parts of the world and serve the consumers around the globe. So there is a recent study from Zero Waste Scotland found the carbon footprints of food waste generated can be higher than that of plastic. For almost 500,000 tons of food waste produced in Scottish households contribute to 1.9 million tons of CO2, which is 3 times higher than that of plastic waste. So this is which one is lesser evil? Is it plastic or is it food waste, right? So there is another very interesting figure I would like to show, the long food supply chain. It is also a very complex network. Just think of Europe alone have 12 million farm produce agricultural products, which are processed by around 300,000 processors or companies and distributed by 2.8 million food retailers and serving 500 million consumers. So this is a mammoth, the network, a complex network. And there is another study which I mapped it when the food from the farm until your fork, it has been handled 33 times or touched 33 times. So the 33 times there is a risk of safety, quality, wastage, mishandling, all those elements are there. So more longer the supply chain, more complexities, the handling of food can have also more risk and that may be the reason why the cucumber are wrapped in plastic. Just think about this, more than 50% of the food waste takes place in household in the UK context, and nearly 20% wasted during the processing. So just a very interesting fact here. So use up 1.5 gram of plastic film of wrapping a cucumber can extend the shelf life for 3 days, from 3 days to 14 days. And grapes if we wrap grapes in the plastic bag, it can reduce the in-store wastage to 20%. So that is the impact of how plastic help us to reduce food waste, right? So there is another very important element here I would like to show you, that we often come across that how about the food naturally wrapped in its own skin can be safely transported. That is true without single-use plastic. But it's a very interesting research found that it can only possible if it is short food supply chain, if it is locally sourced and locally consumed and not traveling too far. If we don't grow mangoes here, but if we like mangoes in a season which is not producing mango, it means it has a cost, it has the different logistical arrangements one need to do. So research, so if it is not a short supply chain, this naturally wrapped, not using single-use plastic is quite very difficult. So we need to really find alternatives. What can we do to satisfy the needs of the consumers, requirement of the consumers, and also reduce the use of plastic, right? So now comes the alternatives. We often go for what about glass? What about carts? Yeah, which can also transport easily. True, but it can increase the cost of transportations because of the weight and because of the inflexibility. And that another research, my colleague Eleni does that. That the transportation cost increased dramatically when we use alternative packaging materials such as glass and cardboards. So what are the possible solutions? How do we configure a short food supply chain that the alternative, farming models, urban farming, hydroponics, and vertical farming? These are some of the examples which could be, developed further so that we can more rely on the short food supply chain, and that will also reduce the food waste and also less use of plastics, and also more beneficial for the climate and environment as well. How about using more circular economic model, for example, more use of reuse, redistribute, recycling, remake, those elements, if we can bring it to our processing and packaging of products, that can also help us quite a lot in removing plastics, or even reducing plastics in our supply chain. Then another very important element is to prevent leakages using technology. How about, we have now blockchain technology and other track and trace technology available. How about bringing those available so that all the plastic used in the process can be tracked and properly recycled somewhere else? Besides, the last one is there is more looking for bio-based packaging, but sometimes it is also debatable, and it's one for the future research, that how sustainable it is to use other materials to really, sometimes some materials can be more expensive to make them. So how do we use bio-based packaging for the future packaging? So this is very briefly I summarized, how food, plastics, and climate play a role, and I'll be happy to answer any questions if you may have.
Thanks, Manoj. That was lovely. Would anybody like to ask a question briefly? No, it's very interesting. The idea of the interplay between all those different factors, of course, absolutely fascinating. And the complex nature of those supply chains is also interesting in my view. That's an interesting way of thinking about it. Thank you very much.
Thank you.
We're going to try and have another go. Simon, would you like to just say something? And we'll see whether we can hear you. I don't know whether he's there.
I think it's disappeared, Jeff.
And is Mike there?
Not yet, unfortunately. So
right.
So we can take any questions, or
would anybody like to ask Manoj a more detailed question?
Jeff.
Yes.
It's Colin. I could pick up. I've got Simon's slides. I can pick up and give a.
Yeah, could you for sort of up until about 22?
Yeah.
Quarter to? Yeah. Look. Yeah. Go on then.
Let me just.
Let's do that then.
Come on, where are they? Yeah. Oh, fiddle! I'd opened the wrong file. keep going, and I'll pick it up at the end.
Okay. Does
Oh,
Tom?
Mike too. Sorry, so you said Mike's not there. Sorry.
Yeah, it's not. No.
Hang on. I will have it in just a sec. Oh, for goodness sake.
One needs to make one's own entertainment for a second.
See,
Yeah.
Simon's returned.
Simon, are you okay? Is your sound back on? Your volume?
Doesn't
Can
seem
you hear me okay? Can you hear
Yes,
me okay?
yes, we can. Do you want to pick up where you left off then, please?
Yep, I'll just go to the presentation. So. And so looking for the, sorry about this, fluent with the other ones, but not right. I think we're going for that. Can you see the image now? Can you see the image?
No.
I've got to press share.
Yeah,
Can you
it
see the image
started.
now?
Yeah, we've got it now. Off you go.
Got it.
Yes.
Good. Okay. Can you remind me where I got to?
Yeah. If you'd done that slide.
Yep.
And we'd had a look at the next one.
Yep.
If you could move on to number 3. Yes, we looked at that, and you were describing the number of jobs, and then sound went on the next slide.
Okay, right. Okay, so back to employment. Thanks so much. Sorry about the interruption. So what I've done here is to take the 21 million, which if you recall was the employment by the UK, the service industry in 1990, and set that a unity of 1 on the left. And that enables the comparison between 5 countries. With respect to that, we can look at manufacturing, another major industry, comparing the green and the red, which is Italy and Germany. That's 40% compared to service industry in 1990. But the UK is down the bottom at 20, and you can see since then it's gone down to 12% of the service industry in 1990. Yet the service industry itself is growing. It's just a way of saying not only is the service industry a major employer, but it's a very typical behaviour of developed countries. Now going over to the emissions, and this is staying with the UK. This is now all the greenhouse gas emissions. So the band at the top is for the non-CO2, that's the methane and so on. And then the CO2 are from the green all the way downwards. Now you saw from the graphic that we interpret the emissions as coming not only from fuel, but electricity, goods and construction. And when we do that approach, and we see here, this is now the bottom band. This is the unusual way of doing it, but we feel is appropriate because the full footprint of the industry. And you can see this is significant at about 20% and been pretty constant over that period. So we've got 2 things to worry about here. One is that the full footprint of the service industry is not insignificant. It's not 4%, it's 20% here. And furthermore, it's a major employer. So if you look at the butt at the bottom, clearly, if we have a recession and the activity in this industry goes down, we can reduce emissions in a very crude way, but that's unacceptable because it gives rise to unemployment. We have to maintain employment, which is predominantly through the service industry. And yet, by looking at this, we can see we're not going to achieve our emissions targets. We've got to figure out how on earth to get the emissions down. Now we jump to the conclusion. What I was showing in the previous slide in the blue band was the emissions from the service industry historical for the UK, and these are the orange dots here, because this now is showing both the past, the historical, and the future. What we've done is a modeling approach, which enables us to be calibrated from historical and go all the way through to 2050. Furthermore on here, the black curve is for the imports. A major part of the footprint is from goods, and as we well know, a lot of those goods come from abroad. So not only have we looked at the imports historically, the black dots on the top left, but we've included that in our scenario. Hang on now to the black envelope, because it's now going to be filled out by all the components. Okay. Take an example, the second one down is red for electricity. And as you can see, it dwindles down to nothing by 2030. And we will hear about decarbonisation of electricity, and that comes through on our scenario, yet a number of others are carrying on at very high levels. And this is what our scenario is showing. Our scenario is called with existing measures, and by existing measures, we've gone with the 5th carbon budget. The bottom 4 bands from the orange downwards are what's referred to here as CF for capital formation, which is construction. And this is equally important. So the buildings you're in, any building work that goes on, and the offices, hospitals, shops, and so on, hospitality, they all need construction, and that's a major footprint in itself, which we've included here. We have to do better than this. This is the thrust of the presentation, to say it's not low, but it needs to be considered and reduced. The way we go about this is we break down all the inputs into disaggregation. In terms of goods, we look at all the separate goods, electronics, print, matter, materials, and so on. So this is the example for one of these goods, let's say, and we compare the need for the input of goods, that particular one, to the output of the industry, and that gives rise to the ratio here. This particular example, you see that ratio is declining in the first 15 years, which is good, but for the most recent 15 years, it's flat. And so in terms of our projection method, we continue that as a constant one, as you can see, the black solid line. What we then want to do is to say, how can we reduce? And because here we're talking about materials, that would be the dematerialization, as I've shown. And we've explored the literature to find every possible way that's conceived to dematerialize. And then what we've done in the scenario is to put a rapid implementation of a dematerialization policy and a slow one. That gives us 2 curves in order to give rise to 2 types of scenario. This is now the result, and I'll draw your attention to the red curve. So what we're looking at here is a scenario including the imports going as fast as possible with all the policies that we can find that other people have said might be possible for various things, dematerialization and all the other things as well. And you can see it flattens out at about 35. That's not going to enable a net zero carbon future. This is a major one. And so this is where we talk about with additional measures, all these additional ones that we're talking about. So to draw it to conclusion, the service industry, not only the key part of GDP, we're not so worried about growth, it is a major employer. It's up at about 90%. It cannot be ignored. And yet we're not looking at the footprint of the employer, the employment place, let's say. It's separating out all the benefits of the services. Many goods are still increasing. I didn't go through in details, but I've noted 4 of them here. And the problem is that implementation and reduction rates have been minimal to date. There's no attention focused specifically on that. It's going to be big in 2050. There are 35 million tons. And so the implementation of mitigation measures has to be aggressive now. And more crucially, we need to do the groundwork to see how to bring about the measures so they can then feed into policy and implementation. The last slide here is this is on the shoulders of work with many colleagues. You can see it on the bottom. With Colin also at Brunel University in Australia, University of Edinburgh and INSEAD. And there's a couple of papers there which go into some of the details. The material here is from the one Roberts SH from 2021 this year, and also a couple of lighter ones which go through a bit more on the methodology. Thank you.
Thanks very much, Simon. That's really interesting. And so I guess you're saying that really the government needs to be introducing policies now to address this, and it needs to be part of the way in which we're counting our carbon. Is that the that's the big really big
if you go back to if you consider the greenhouse gases slide,
yeah,
this one here, you look at freight transport and passenger, we hear a lot about that. So a lot of attention, it's not easy. Electric cars, you look at dwellings, that's in the news this week, whether heat pumps will work or not. But the thing is, it's out there being talked about. The challenges of transportation, the challenges of dwellings. No one talks about the challenges of the service industry. So it's not even being considered, and it's not included in the metrics.
Yeah, okay. That's interesting. Does anybody want to ask a question briefly? All right, thank you very much, Simon. So anybody thinks of something, please drop it into the chat, and I'm sure speakers will be happy to respond with
the clock. So welcome back to those who are here for the first session, and welcome if you weren't. If you are new, just to let you know that the session's being recorded, and we can use the chat to ask questions into real time as the speakers are going through. We'll hopefully have time at the end of each talk for 1 or 2 questions if speakers stick to their 10 minutes, and we'll aim to finish round about 5 to the hour to give everybody a little bit of a break before the next session. The first session we heard a couple of the speakers talking about interactions between different factors and trade-offs, and the fact that you can't consider some of the issues involved in climate change in isolation. And we're going to hear more about that in the talks in this session as well, starting with Yurui Fan from Civil and Environmental Engineering, who's going to talk about compound hydrological risk analysis. So 10 minutes, please, Yurui, and over to you.
Okay, thank you very much, Trevor. I'll just share my screen. Okay, and good morning, everyone. My name is Yurui Fan, and I'm a lecturer at the department. Okay, my voice.
That's good.
Okay, so the topic of my presentation is compound hydrological risk analysis and climate change. So as we all know, extreme climatic events usually lead to severe losses. So some typical examples such as the 2021 European floods and also the Henan floods in China, and also some floods or some extremes, they may be correlated. This will lead to the compound extremes with multiple attributes. Moreover, the new IPCC report also defined that the compound events may not necessarily result from dependent drivers. However, this report just included that the impacts of the concurrent extremes on land areas have increased with a high confidence. So the compound events may trigger significant consequences much larger than the sum of impacts from individual extremes alone. So without considering of the compound extremes, so the risk reduction efforts targeting one type of hazards may increase exposure or vulnerability to other hazards in the present and future. So it's designed to address multi-hazard risk analysis of compound extremes and climate change. However, there are still some challenges to do the risk analysis of compound extremes. So the first one is generate reliable climate projections. So in general, there are a great number of climate models, such as the GCMs or RCMs, and different climate models may produce discrepant climate projections. So, and also currently, the best correction measures are developed only based on individual model outputs. So these measures can merely reflect one-to-one relationship to simulations and observations, and also neglect uncertainties resulting from model parameters and input conditions. So we need to develop advanced measures to generate reliable climate projections. The second challenge is quantify interdependence among extreme variables. So in general, the compound extremes consist of multiple drivers, and the interdependence among these drivers may be complicated, such as we may have nonlinear structure between these drivers. Traditional statistical measures, such as multivariate distributions, may not reflect these complex dependent structures. So especially for the extreme variables with different marginal distributions. So we need to propose some studies to characterize the interdependence among extreme variables. to address this above two challenges. So the objective of my study is to propose one coupler ensemble downscaling measures for climate projection, and also propose a hot drought probabilistic recognition system for combined events of drought and hot streams. Okay, the first part I want to introduce the one coupler ensemble downscaling measures, or VSET. So in fact, in the VSET measures, the one coupler will be proposed to reflect interdependence among the information from observations and also from the ASEM projections. And then the probabilistic distributions will be derived for the downscaled variables conditional on the projections from the ASEM models. And then these distributions can provide the basis for jointly downscaling the ASEM projections in both deterministic and probabilistic expressions. So here in the VSET measure, the basis is to use the coupler function to establish the relationship between ASEM simulations and the real observations. So in general, coupler functions can connect univariate distribution functions to form the multivariate distribution functions. So the one coupler is to decompose a multivariate function into a set of variable coupler densities related to the original variables and their conditional variables. So like this one, so the joint probability of f x1, x2, and x3 is equal to x1, f1, x1. So the distribution of x1 and also f x2 conditional on x1, and then f x3 conditional on x1 and x2, and then the conditional distribution can be obtained based on the coupler function. So once the joint probability between the ASEM simulation and the observations are established, then the conditional distribution for the downscaled variable here, like this equation will assume xn will be the downscaled variable, and x1 to xn minus 1 will be the variable the projections from the climate models. And then if we have new projections, then we can get the best practice projections from these equations, Okay, so this developed method has been applied for precipitation projection over the lowest plateau in China. So in this area here, we consider two climate models: the PRECIS model driven by Hydrological, and also the Residue model driven by the GFDL. And here is the outputs without bias correction from the ASEM models. So the black line, the black curve is the original observations, and the blue curve is the outputs from RegSim, and the red curve shows the projections from the simulations from PRECIS. So we can see that there are significant discrepancies between the ASEM simulations and the real observations. So we need to do bias correction to generate the accurate projections. So this plot just compared the bias correction between the VSET method and also some traditional measures such as QMAP and bicoupler method. Here as the black curve is the real observations, and the green curve shows the bias correction from the VSET method. And also other dots just present the bias correction from traditional measures. Here from this plot, we can conclude that the VSET method can identify significant information in the discrepant ASEM outputs, and also we can get more robust projections. And also here, based on the VSET method, we just generated the the precipitation over the lowest plateau in 2050s and 2080s, and the two RCPs, RCP 2.5 and RCP 8.5. So here, based on this plot, we can conclude that the project future precipitation in most areas of the lowest plateau are higher than the corresponding values from historical observations. So especially in the western region. And here is a brief conclusion. In our study of one coupler ensemble, downstream methods have been developed to generate reliable climate projections from multiple model outputs. And also the VSAT method would generally have better performance than traditional QMAP and bicoupler methods. So the application of the VSAT to the lowest plateau indicates that more precipitation may be expected in future. So if you want to know more details for this study, you can refer to our paper published on water resources research. So the second study is about the risk analysis of drought occurring with hot extremes over the lowest plateau. So here, this is a model framework. So as I just mentioned, here we consider the temperature, which is best corrected by the QMAP, and also the precipitation, we just best corrected from the developed VSAT method. And then we just establish the risk analysis of the combined events based on coupler, and then get the risk analysis and the climate change. And also here we need to use the coupler method to establish the joint probability between the drought and hot extreme. Here, if we consider a common event as decorrelated attributes, then the joint probability can be established based on the coupler function like this one. And also under the multivariate context, the risk indices may present different scenarios. So traditional for the univariate risk analysis, we consider some risk indices such as the return period. But under the multivariate context, the return period can be presented in different scenarios. So the first one is T-end, so like this plot. So this joint return period just describes the occurrence time interval that all the components, means U1 and U2 of the combined extreme exceed the prescribed or predefined threshold. And another case is TOR, so as shown in this plot. So this return period describes the occurrence time interval that at least one attribute exceeds the predefined threshold. And the third one is the return period in candle. So this means that this describes that the occurrence time interval that the combined extremes exceeds a critical layer. That's this one, critical layer. So this means
just one more minute, please, Yuri.
Okay. Okay, I will finish very soon. Okay. So and also I just use this method to the lowest plateau area in China. So here is the plot. This means that here from this plot we can see that the SPR value, this means standard precipitation index, will be larger than those in the historical period. So this means that the severity of the drought may be reduced. And also the 50-year return period of TX90P value for this region will be obviously larger than historical ones. For the joint return period, we firstly consider the joint return period with the SPI is equal to -0.5 and TX90P of 60. So this is considered as the mild drought with middle long-term high temperature. So the results indicate that the return period for this event are significantly smaller in future. And also we consider another compound event, which is SPI is equal to -1 with Tx 90p of 90, which is considered as a moderate drought with a long-term high temperature. So here, the results indicate that the species suffering from the compound extremes are mainly located in the southern part of this region. So here is a brief conclusion. So here we just developed a hot drought probabilistic recognition system. So the results to the lowest plateau indicate that future species in future may suffer from severe drought with long-term hot extremes. However, some species may also experience a high frequency of drought with long-term high temperatures in the southern and south central regions. So this study has been published on Earth's Future in 2019. So this is my presentation. Thank you very much.
Thanks very much, Yuri. We are a little short of time, so if anybody does have questions, just type them in the chat. I think that the message, or one important message from that presentation is the differences between different places in what we might expect, and I think that's one of the challenges with climate change is having regionally reliable models. And how we explain to people that those variations are part of the predictions, and we need to work with them. Excellent. We'll come back to some of those same issues later. The next talk is by Salman Masoodi from Chemical Engineering, who's going to talk about biomass combustion and post-combustion carbon capture. So over to you, Salman.
Thank you very much, Robert. I'll just share my screen. Right.
Okay, that's good if we can see it.
Okay, fantastic. Just you bear with me 1 second. Just adjust this. Right. So good morning, everyone. I'm Salman Masoodi, Senior Lecturer in Chemical Engineering. So in this brief presentation, I'm going to give a short yet general overview on carbon capture, utilization, and storage within the context of low carbon energy production, with a taste of my research around the application of biomass combustion residue in post-combustion carbon capture. So my current research around carbon capture and hydrogen generation basically is centered around 4 main themes, as can be seen here, which are post-combustion and direct air capture, seawater decarbonization, and low carbon energy production. Now, today's presentation is going to be more focused on my research around post-combustion carbon capture. So I will continue this presentation by providing an outlook on the current status of carbon emissions. I will then introduce CCUS and BECCS technologies, and then my talk will then conclude with a brief overview on my research around BECCS at Brunel. So it is evident then that the atmospheric concentration of CO2 has been on the rise within the past decades. So currently it is standing at about 416 ppm. As it can be seen here, there has been a clear steep rise in carbon concentration just within the past few years and well, few decades really. So there has been a significant increase in global carbon emissions, as seen here, most of which originating from transportation, industry, and power sectors, as evidenced on this graph. Now, this slide shows that carbon emissions basically have been on the rise in 2021 across the most polluting nations. Now, the continued and in most cases the increase in coal-based energy has been another contributor to the observed increase that we have basically just seen. As reported just a few days ago, climate impacts basically have sadly led to a considerable loss of lives around the world and imposing huge economic costs. Right, so in December 2020, the UK announced its ambitious 10-point plan to meet net zero emissions by 2050, which will bring about a significant economic boost to the nation. Now, the interesting thing is that the 8th point in this plan is specifically dedicated to carbon capture, utilization, and storage, with significant funding to support industry and create new job opportunities. Only a few months ago, the UK announced its industrial decarbonization industry, which which aims to generate 20 terawatt-hour per year of low carbon power in industry by the end of this decade, while capturing 3 million tons of CO2 per year, which is a significant number. Now, the question is, what is CCUS? So CCUS simply refers to a collective set of technologies that comprise capturing CO2 and then either using it to produce other value-added products or permanently store it underground. Now, CCUS is typically classified into post-combustion capture, pre-combustion capture, and oxy-fuel combustion. Now, post-combustion capture, the topic of this presentation, simply involves capturing CO2 at its emission points, such as power plants. As seen on this map, there are currently 65 commercial CCS plants across the globe in various stages of development. What are basically the main technologies for post-combustion carbon capture? So here you can see 3 processes, including post-combustion carbon capture, among many others, that exist. Now, each technology comes with a set of pros and cons, obviously. However, while absorption processes, that is using liquid solvent to remove CO2, are the most conventional, absorption processes, which are using solid sorbents instead, are becoming more and more important and are now known as the second generation of capture technologies, which are to be heavily deployed within this decade. Now, the question is now, what is BECCS? So it is simply a negative emission technology. So the combustion of sustainable biomass is a net zero emission process. And this is very simple to understand. So it is simply because during the combustion of biomass, only the CO2 that was previously removed from the atmosphere during plants' growth is put back into the atmosphere. However, if this CO2 is further captured, i.e. BECCS, we will be looking at a negative emission process which combines biomass combustion and post-combustion carbon capture. Negative emission technologies, including BECCS, have been identified to be an inseparable part of the roadmap to meet the climate change target, as seen on this graph. By 2100, negative emissions would need to exceed the remaining emissions. So this simply translates into a net reduction in atmospheric CO2 by the end of this century. There are only a few commercial scale BECCS plants in the world, with many more to be built in the years to come. Now, Drax power plant in the UK, traditionally a coal-fired power plant, is currently the world's largest biomass combustion plants. Now, I'm going now to move into what I do around BECCS at Brunel and in my research group. So upon the combustion of solid fuels in power plants, 2 types of solid residues are normally generated at 2 different locations in the process, namely fly ash and bottom ash, as seen in this photo. Now, the byproduct of fossil fuel biomass combustion is a generation of various types of solid waste residues, such as boiler slag, bottom ash, and fly ash, as you just saw. Now, a great portion of this waste is being landfilled, causing a series of environmental concerns. In my research, and owing to the particular physical and chemical properties of biomass compared to coal, I have partnered with Drax power plants to investigate the potential efficiency of reutilization of biomass combustion residues in post-combustion carbon capture. Drax fly ash it contains a range of inorganic phases, as seen here in the characterization that we have done here at Brunel. Now, the spherical particles seen here in this SEM image are simply formed during the rapid cooling in the boiler, as the particles are formed and descend in the boiler. We have managed to use industrial grade biomass combustion as simply Drax power plants biomass ash to synthesize 2 types of adsorbents for post-combustion carbon capture. So what we have simply done here is simply using a waste material to extract 2 important yet cost-effective sort of adsorbents that we can use to capture CO2 at the emission point. Some physical characteristics of our porous carbon is seen here, which indicates a porous nanostructure of, as confirmed by the SEM image. Our virgin, or in fact non-modified adsorbent, has shown promising CO2 uptake capacity, which can be linked to the presence of ultra microporous structure of the adsorbent. So it is very nicely comparable with commercial grade adsorbent material that have been using CO2 capture. Now, the mass transfer behavior of our adsorbents will then be investigated in a fixed bed reactor, which we designed and basically built in my group. And the next phases of this project basically involve understanding the equilibrium and kinetic behavior of the adsorbents, activating the adsorbents, and also doing some process modeling, which is informed by our experimental data. This will simply then lead to the techno-economic analysis of the entire process. Now, these are some other funded projects on carbon capture as well as hydrogen production, which I am currently carrying out. It may be worth mentioning that within the second phase of the base funded project here, the second project that you see from the top, first in kind pilot scale capture unit will be a detailed design, constructed and operated at a capacity of 100 tons of CO2 per year. So this is, I guess, one of the most interesting sort of research that hopefully will take place from 2022 onwards. Some of the publications that we've had around this research area are also listed here. And at the end, I would like to thank the dedication, hard work, and scientific rigor of my research group members, as you see them here. I would also like to thank our head of department, Professor Sheng Dai, and Professor Tassos Karyanis, for their continual support of my research through the past years. Also, I would like to thank ETC staff and Mr. Abdul Ghani for their continued support throughout my research. So I think I can, this is just basically the end of this presentation. I can stop sharing the slides now.
Thank you very much, Salman. Does anybody have a question for Salman? We've got a couple of minutes. Yeah, Genevieve.
Oh, no.
No. Okay.
Thank you very much.
I mean, I suppose just a very sort of arm-wavy question. I mean, how optimistic are you about carbon capture as being able to make a significant contribution to CO2 reduction?
So if you look at the IPCC report, so Intergovernmental Panel on Climate Change, carbon capture is an inseparable part of carbon reduction to net zero by the middle of this century. So unless we have carbon capture in place, it would be impossible to reach the emission target that we have around the world. In terms of technicality, well, this process has been in place for decades, so it's not something that we're not really inventing the wheel. We're simply just trying to make the process more energy efficient and compact. So it's more, I guess, down to the political incentive, whether there is going to be this political incentive around the world to just make sure that we're capturing this CO2. Now, the good thing is that capturing CO2 would allow us to basically continue burning fossil fuel based we'll continue burning fossil fuel, but at the same time, avoid polluting the airs.
Yes, okay, thanks for that. Excellent. We'll move on now. The next two speakers both come from environmental sciences, starting with Ariana Zika, who's going to talk about population impacts of climate change. So over to you, Ariana.
Thanks very much, Trevor. I'm just going to share my slides at this point, and I think I want to make a comment on Salman's just latest comment that I don't think we should continue to burn fossil fuels. I think the planet is heading for a very uncertain future if we continue to do so. So stopping there with a comment, I'd like to continue with my presentation. I am an environmental epidemiologist and population health scientist based at the Environmental Sciences Division. And all I want to show in here is a bit of a showcase of the work that has been taking place while at Brunel in relation to estimating the impacts of climate change on populations, but also looking at some potentials for capacity building. So I'd like to start with the research. And I know there's going to be just a very short case, a very, very brief notes on the work that has been going in here. And I'd like to start with the concept or the framework of what the impacts of climate change are in populations, which is based on my very good colleague, Colin Butler, in Australia. And those impacts are the way that we think about this in terms of populations are primary impacts. So we look at direct impacts such as heat or cold stress or physical trauma. Secondary impacts, or biological, ecological impacts, such as those over here, daily, vector-borne disease. COVID is not an unusual scenario as well, or and also vector-borne diseases and food security or changes in crops. And tertiary impacts that are as a result of pressures or societal pressures and or otherwise called socioeconomic impacts. I'll talk about some research done in all of this. I'm not going to showcase all the research that has been going on at Brunel, but just some of those. And starting with the primary impact. So, sorry.
Oh,
bless you. This is a study that was done in Ireland. This is some years back, but it's a study that in some ways it kind of initiated the work that I do in this field with climate change. For the past decade. And it's a study that was funded by the Centre for Research in Aging and Development for the whole island of Ireland and wanted to explore the impacts of cold weather on mortality in Ireland and look at the differences in the two jurisdictions and try to understand why those differences in mortality were. But also looking at fuel poverty and age as key determinants of what we observed in terms of estimating the impact of cold weather on deaths. So this is a first study which was caught up in the media as well and quite widespread, and also informs that you can see one of the photos down there of my colleagues at Dublin Institute of Technology with the Minister for Communication, Energy and Natural Resources that took forward actually in terms of policy making for fuel poverty. So another massive work actually that is being done in this area is through the Mortality and Climate Change Collaborative Research Network. So this is an international research program that is trying to understand the associations between environmental stressors, climate and health. And at this point, there are over 660, or I think it's plus actually, cities and more than 40 countries and of course multiple institutions. And this map shows where the data is coming from and where this network comes from. Brunel is part of it. So one of the most notable studies that was published in 2017 is the one that looked at climate change projections based on the RCP, the representative concentration pathway scenarios, and looked up to 2100. And what this study showed that we are actually heading for an increase in the numbers of deaths as a result of a heating planet. And again, this was caught up in the media. This is a Guardian extract, or just a key summary of the Guardian that Southeast Asia is the one that will be mostly impacted, followed by Southern Europe and South America. Another notable study, which is very recent, was published in May 2021, Nature Climate Change, is looking at burden of heat-related mortality attributable to recent human-induced climate change. So again, it's part of this big network. And what it shows, this is excerpt from The Guardian again, that it's about 37% of all the heat-related deaths in all the locations studied, considering that we haven't included the whole world, will be attributable to anthropogenic climate changes. And this is just a list of what this network is working on or has published already and is still ongoing. So it's really active and producing more research, epidemiological research in this area. So another topic which is of my interest and a few other colleagues at Brunel is migration induced from climate change. So I've written here a lot of numbers and statistics just to show that there is a huge impact that is already seen by in terms of forced population displaced or forced displaced population. So it's about 82 million forced displaced people worldwide. This is a measurement by the UN Agency for Migration at the end of 2020. And about 30 million are internal displacement associated with disasters across 145 countries. So again, the projections, and intentionally I've made those numbers very small, so you don't have to read them all. There is a lot of estimates of how many people will migrate and what is the impact of climate change. However, the main observable estimation is that all those numbers are going upwards, and climate change will be a significant factor in movement in the coming decades. And I think one key thing to note is that there are large inequalities in those numbers. So while we have 1 in 95 people worldwide forcibly displaced, 48 of these are internally displaced. About 68% of the internationally displaced originate from only 5 countries. 35 million of these are children. And while about, roughly 90% of the refugees are hosted in developing countries, about a third of these are hosted in the least developed countries. This is some research that we've published. Rebecca Parrish is a doctoral researcher working with me at Brunel. And we're trying to understand what are the key drivers of migration and how is climate change a mitigating factor, potentially, one of the key main drivers interacting with social, economic, political, demographic, and other environmental challenges. While we have developed a conceptual model, we're also looking to do an epidemiological study, and is in the process of being now trying to understand the links between climate, food security, and migration as push or pull factors. And again, there is a publication by Rebecca Parrish. Within the context, there was an initiative in the context of trying to understand the climate change, but also the planetary health changes, and how do we monitor this, and how do we quantify those impacts. So an initiative in 2019 that invited different stakeholders. I was part of that group, and from that initiative was derived a migration working group, for which I'm the lead, and also colleagues from Brunel, who are, I think, here today, are part of the group. And the key aim of this group is to address current research gaps in linking environmental and climate change human movement, and also be able to establish a pan-disciplinary multi-stakeholder expertise with a focus on most vulnerable communities, but a key goal to inform actually policymaking, prevention, and mitigation strategies. I was invited as a Monaco workshop experts in 2019 to look at and try to understand the links between ocean pollution and health, population health. And this was a workshop which led to a major report written where climate change is a key driver in that interlinkage between ocean pollution and population health. And this report was published in 2020. Another aspect of my work at Brunel, for over 20 years now, is capacity building and infrastructure for environment and health. And I'd like to introduce the concept of environmental public health tracking, which is the ongoing collection. So it's monitoring, integration analysis of quantification and estimation of environmental hazards, exposure to environmental hazards, and the link to human health, and using that information to inform policymaking. This environmental public health tracking as a concept was implemented by the United States Center for Disease Control and Prevention in 2003. It's followed by many other national health authorities across the world, including the Public Health England, who I work with very closely. And as a result of this need to take environmental public health tracking as a key tool for informing policymaking, is the INFAT network is created, which is a network of national health authorities and some academic partners, including Brunel in this case. And I represent an informal steering committee and scientific committee for this network. Some publications of this network are the ones that I'm showing, where how we try to advance global health through environmental public health tracking, but also how to integrate environment and health data that inform policymaking. Another initiative, and this is my last slide, is talking about capacity building. And there is a network which I'm part of a coordinating group for establishing training and curriculum change for physicians, so that we can have sentinel physicians for the environment who, within the clinical context, can detect and protect population from environmentally driven diseases, and also inform and increase awareness, but in the policy context can detect and inform on classes and emergency events, and have the ability to rapidly respond or participate in response to disasters. And within the social context, understanding the adverse impacts of environmental pressures, ecosystem change, and also potential to address inequalities overall. And some work that is very relevant to this that has been published is also this, a couple of recent papers that this network has published in regard to this capacity building. So I'll close in here and I'll take any questions. Thank you very much for listening.
Thanks very much, Ariana. Yes, does anybody want to ask a question? We've got a couple of minutes, so.
I have a question.
Yeah, please.
This might not be completely related to health as such, disease, but more mental health. I was just wondering if there is any kind of tracking in how, as the climate is changing and it causing pressures on community, if there has been any correlation between pressure and conflict.
I think there are a number of studies. So if you're looking at the estimating that link, I think there are a number of studies that look at that. If you think in terms of tracking, as a tool for informing policymaking, mental health is becoming more and more, a key health indicator for many national health authorities. So I think it is part of the process of tracking.
But I don't mean just on the individual. I mean as a collectiveness in entire communities. As this is just kind of imagining. I mean, some of these very vulnerable communities that you have, where they're not able to plant their crops anymore, and they have to move into other areas where there are other people. Suddenly you have resources, or a lot of pressures are being put on resources. And we all kind of know that as the moment there's stressors, people can behave very unpredictably. So I'm just kind of curious if that is something that are being looked at, and tracked around the world, how pressures come, and then that could cause conflict in various areas, not just mental health.
Yeah, I think it's a lot of research that has looked at migration and health, and mental health has been one key aspect of health in those. So it's an increasing, awareness, and also scientific research into looking at resource security and conflict as drivers of migration, and therefore as drivers of those health indicators. So I think just looking for that scientific evidence, because I know there is quite some.
Yeah, because policymakers do need to, I suppose, need to take aware or be aware of these kinds of things, because as we go into a lot more pressures being put on even developing countries, with all of these, we all have to do our bit, obviously, to stop climate change, but it's going to put a lot of financial pressure on everybody, and that will have consequences, long-term consequences, I think, on everybody. Anyway, thanks very much for that.
Thank you very much, Angelique.
Yeah, no, thanks for the question. We'll move on now to the final speaker in this session. We do need to finish just a couple of minutes early to give people a break. So we're going to finish off with Sibylle Erlenmeyer, also from Environmental Sciences, talking about climate change impacts on agriculture and the consequences of those.
Okay, good morning, everyone. I think I'm just going to stop my video before trying to share the right screen. Can you just confirm that you can see the presentation?
Yeah.
Okay,
Yeah,
great. Thank you very much. So yeah, first of all, I would like to thank you for giving me the opportunity to talk about climate change and health. And I would also like to thank Ariana for a great introduction into the bigger picture of climate change and health. Today, I'm a human toxicologist, excuse me, working in the Division of Environmental Sciences. So my interests are mainly in the exposures to harmful chemicals and how they can have an impact on health. And why I'm talking to you today is because I'm also interested in how the impact of climate change on agriculture, and if this might be increasing human exposure to harmful chemicals. I'm just trying to move the slide. Okay, so climate change has been recognized, as we just heard, as one of the single biggest health threats humanity is facing today. And we also know that the people that are impacted the most usually contribute the least to the climate crisis that we're facing. So these are people from low-income countries and usually also the most disadvantaged communities. Recently, there have been several reports, like the annual Lancet Countdown on Health and Climate Change from 2020, but also a 2021 WHO report on the human and the health argument for climate action. And then there's also a report from the Royal Society and several others that are now bringing together health and climate change, and yeah, the challenges that we're facing. So we know that we have health impacts from extreme weather events such as heat waves, storms, floods, and this then leads to disruption of food systems, leads to increases in zoonosis and other diseases, including infectious diseases and non-infectious diseases. And then, as we just talked about, it can also lead to mental health issues. And this has also been recognized, and several studies are out on this. But I'm especially interested in how climate change impacts agriculture and in turn the use of agrochemicals, which may impose a risk to human health. Climate change has a major impact on agriculture through warming and drying trends, as well as more variable rainfall patterns. We overall observe an increased intensity of extreme weather events, such as hurricanes, floods, and droughts. And the consequences for agriculture are increased risk of crop failures due to heat stress and introduction of new plant pests and diseases. So the agricultural yields increasingly depend on more and more crop protection measures. So the increased risk of crop failures and new plant pests and diseases put the livelihoods of farming communities at risk. It likely causes changes in agricultural practice, including a change in the use of agrochemicals to mitigate new pests and it also reduces soil productivity. This in turn may lead to either an increased or a changed exposure to agrochemicals such as pesticides, and this again can have a negative impact on the health of farmers, farm workers, their families, and also the consumers of the products. So we know that agrochemicals such as pesticides can have a wide range of negative effects on human health, both after acute and chronic exposures. The exposure to these chemicals is particularly relevant during early human development, such as during pregnancy and childhood. And exposure to these chemicals in the womb can disrupt healthy development and increase the risk for a plethora of diseases in later life. So we know that the climate change related weather events already have an increasing negative impact on the health of farmers and their families, just from the before mentioned mental health impacts and due to the heat and yeah, the adverse impacts on their livelihoods. But as you just heard, it might also cause a changed or increased exposure to agrochemicals, such as pesticides, insecticides, and fertilizers. And these impacts are most probably the highest in vulnerable groups in these communities, such as the pregnant women and children. So to investigate how the climate emergency may also increase the health risk from exposure to harmful agrochemicals, I'm currently working on an interdisciplinary research project where we study the health impacts of agrochemical exposures in response to climate change with a focus on the most vulnerable communities in the Caribbean. Unfortunately, we are not as far in our research as we would like to due to the COVID pandemic. So we have some major delays in the research, but I'd like to share the expected outcomes that we hope to gain from our research with you. So we hope to identify changes in pesticide use in response to the climate change and extreme weather events, mainly in farming communities in Jamaica. And we would like to examine the response of chemical regulation and policies to changes in soil productivity and plant pests. Then we hope to determine health issues that may arise from changes in chemical use, and whether they're kind of perceived health issues or actual health issues, and then establish current health concerns and awareness about chemical exposure. And then our results we would like to use to create awareness about the risks associated with chemical exposure and how to protect the most vulnerable members of farming communities. So since I can't share any results with you yet, I would still like to kind of offer some solutions or kind of suggestion on how we could tackle some of the impacts of climate change, especially on agrochemical exposures. So I guess, especially with a view on chemical exposures, we can avoid risks by promotion of healthy, sustainable, and resilient food systems, by implementing policies that promote sustainable farming, and by supporting low-income countries in ensuring sustainable and climate-resilient food systems. So I think, especially in the lower-income countries, it's really important that we kind of promote the sustainable farming systems. But I think it's all around the world that we need better farming systems so we can deal with the challenges that climate change poses to us. And then just as a last comment, for broader actions to address the climate crisis, restore biodiversity and protect health, the recently published COP26 special report by the WHO has 10 recommendations for climate change and health, which I find really useful, also with little case studies. So you can see what's going on all around the world with climate change and health. And with this, I would just briefly like to acknowledge my project partners and the funding from the Royal Society. And then I would like to thank you for your attention. Thank you.
Thank you very much, Sibyl. Questions?
Just going to stop the share.
Anybody want to come in and ask? We've got a few minutes as always, so.
Nadaraja has his hand up, Trevor.
Yeah, thanks very much. Yeah, please.
Hi, my name is Mani. I'm in the design department. Well, one of the points she touched on is the pesticide in the agriculture can cause so much a problem. So have you looked into the technologies available currently to minimize the pesticide used? Because we had a PhD student working in a so electrostatic sprays where we can minimize the amount of waste going into the land instead of going into the leaves. So there are so much of technology being investigated, and I know that we know there are so many technology being applied in countries like America, and we have big land. They could sprays with electrostatic charged, so they can minimize the pesticide amount. I mean, do you have any comment on that, or do you have any kind of understanding on this technology side?
I personally have not looked into this. I know that there's several projects going on one hand, on different ways of applying different chemicals, but it's also kind of finding more climate resistant crops, things like that. So there's a lot of different research going on how this can be dealt with. And I think also kind of planning, usually during the year, people have their know what to expect, but then you have now this increased extreme weather events where it's getting harder and harder to plan the application. So yeah, I know that there are projects going on, but I don't have any insights into that because that's not part of my research.
Oh, okay. All right. Thank you.
Okay.
Thank you. Ariana.
Hi, Trevor. Actually, I just want to say thank you to Sibyl, but I don't have a question for Sibyl. I have a general question probably for other people that represent the university in this forum. What are the initiatives that the university has taken to address divestment, to address reduction of CO2, and actually, you know, comply with a better future? So just anyone that is in this forum that can answer this question would be very helpful. Thank you.
Yeah, that's a really good question. It's actually quite a hard question to answer quickly. So I'm slightly going to pass that on and say that we will at the end of this term and then at the start of next term be running some briefings. So there's going to be a staff briefing at the start of next term where exactly the questions you've asked, we'll be talking about not only what we have done, but really seeking ideas from across the university about what we should be doing as well from staff and students. So, I mean, I could give you a partial answer now, but in 30 seconds, it probably won't be a very good answer. But there will be better answers to come, and actually, we won't wait until January before sending some communications out around some of these issues, because they're very topical and B, really important.
Thank you, Trevor. I just wanted to also understand whether there is an institutional response to that, not just you know, a student and staff. So not just the bottom up, but up. So if that answer can come sometime soon, it will be great.
Yeah, I mean, the answer is yes, there is institutional response, but what we probably haven't articulated as well as some other universities is a high level statement that might appear on the front page of our websites that says in sorry, I don't know, in 50 words or so, what Brunel's commitment to sustainability is. We haven't articulated that quite as well as we might have done. If you look below, you will see lots of great initiatives going on in different parts of the university and some fantastic things around campus management, for example, and estates management. But we haven't brought that together into that high level statement. And that is something that we're actively working on. So yeah, watch this space is a slightly unsatisfactory answer, but we are working on it.
Great, thank you.
Let's finish off. We'll thank the four speakers for really interesting and sort of thought-provoking talks and some nice visuals with provocations contained within them that we can all take forward and think about over the rest of the day and beyond. We'll give everybody 2 or 3 minutes off now before the next session that Justin Fisher is chairing. So again, you don't need to log out or anything, you can stay logged in. And in about 3 minutes time, Justin will start the next session. But thanks very much to the speakers and for everybody else for being here.
Thanks, Trevor.
Thank you.
Okay, welcome back, everybody. My name's Justin Fisher, and I'm Director of Brunel Public Policy. From Gareth Dale, Devanshi Chanchani, Sartorius Argyroudis, and Christina Webb. And the speakers are going to present for around 10 minutes each, and then there'll be an opportunity for Q&A on all of the papers at the end. So without further ado, I will hand you over to Gareth.
Okay, thanks very much. I hope you can hear me, and I hope my screen is being shared. All right. So initially, I intended to talk about my research on economic growth. I've written lots of papers on the ideology of economic growth, including explorations of its origins, its relation to the rise of capitalism in 17th century England, and other historical questions. I've also developed a critique of green growth, for example, in the book you can see there. And I've engaged in debates on degrowth recently. If anyone's interested, this is all online, either free or through Brunel's e-journals. I was going to speak on this topic, but in view of the shocking news yesterday, I decided to to change tack. And that news is the British government's decarbonisation programme, which makes clear that the government has no idea that we're facing a climate emergency. So I'm going to begin with, just for a minute, I know this is familiar to many of you, just begin with a reality check. This is where we are at the moment. I'm not sure why my slides are not. Yeah, here we are. So this is this graph shows you temperature and carbon dioxide going back, reconstructions from ice core samples from Vostok, the coldest place on the planet, going back a few 100,000 years. And you can see on them the covariance of the two, and also just here, you notice the last 8,000 years or so is an extraordinarily benign period climatically. Nice mild temperatures for about 8,000, 10,000 years or so. That's roughly the period of human civilization. So every document of civilization that we know about, every story, every written document or even architecture that we know of was written or made in a period of very benign climate. And we're about to move, or we're in the process of moving out of that period very rapidly. If you look at the graph, the x-axis is from 0 going back 400,000 years, where 0 is 1950. So let's reconstruct the last 70 years, and you see on the carbon dioxide graph, it's actually rising vertically to a point. It's not, I prepared this slide just a few years ago. It was 400 then, it's 414 today. It's absolutely soaring to levels that we haven't seen for millions of years. This is a more recent, tidier depiction of it. So the Holocene is coming to an end. We're barreling towards hothouse Earth. And the risk is, as we keep pressing our Earth systems, that non-linear developments will occur, very extreme things starting to happen due to cascading tipping points with sudden leaps of temperature in geological terms, you know, maybe, who knows, 2 degrees in 20 years or 100 years. These sorts of things have happened before, with possible shutdown of thermohaline circulation and so on. At the current trajectory, even if the Paris Agreement is held to, which it isn't going to be, we're looking at a truly disastrous rise of 3 degrees by the end of the century. That's the best guess at the moment. Already 40 species of plant and animal are going extinct every single day. That number on average, that's a conservative estimate, and that number is going to soar. And as it does so in the next few decades, by the end of the century and beyond, you know, my worry is that our own species will be imperiled as well. And if there's one single graph that sums up our plight, it's this one. I'm showing it you in 2 forms. So that you can see on the one, the graph itself is carbon dioxide emissions as measured at Mauna Loa, which have been rising inexorably, and plotted against them are the meetings of the COP. So the COP meets every year, and the carbon emissions continue to rise. In fact, they rise even faster. We don't often mention Greta Thunberg and the Queen of England in one breath, but they're right on one thing that they share, which is, as Elizabeth put it, world leaders talk, but they don't do. Or as Greta Thunberg puts it, there's been 30 years of blah, 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 build back better, blah, 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 and so on. She adds, we can still turn this around. It's entirely possible. It'll take immediate, drastic annual emission reductions. And what the British government made clear yesterday is that they're going to do none of that. Nothing immediate, nothing drastic, and nothing annual. They're still going to give out licenses for new oil fields in the North Sea. They're committed to an expansion of aviation. And they even buy into the myth that long distance flying can be sustainable. This sort of thing is just arrant baloney, as I've shown recently with Josh Moose in a recent article in the Ecologist magazine. Now, this sort of project is a symptom of a technology fetishism that dominates thinking among elites worldwide, not just in Whitehall, But in Washington and elsewhere, here's an example from John Kerry, climate ambassador of the United States. Half of American emissions reduction is, America is a world leader, he proclaims, in climate action, but half of their reductions are going to come from technologies we don't yet have. This sort of magical thinking dominates the approach of world leaders and lawmakers, and in Britain too. This is very much the case. The government is banking on carbon capture technologies, which is very speculative technology. It's proven to work, but not yet at scale, and it's currently operating at a tiny scale. IPCC reports have been making abundantly clear for many years that the only way for the world to keep within any kind of reasonably safe carbon budget is to rapidly slow down resource use and energy use. And that means doing things, but first and foremost, with very simple proven technologies like insulating all our homes. This project of insulating homes has been raised by protesters in recent weeks, and seems to me to be a no-brainer. It's everyone's a winner kind of program. People suffering from fuel poverty, their houses are insulated and they're less poor. Far less gas is burnt. The planet is made safer, and everyone seems to be a winner, but this is conspicuously absent from the government's program. So what should we be doing? I think we need to be working on all fronts. It's a climate emergency, which requires all fronts to be worked on. Of course, individual behavior, but also campaigning alongside Greta Thunberg and others, and pressing our government to take some serious action for change. And also pressing our institutions to act as well, which was raised by Ariana in at the end of the last session. Our own industry, academia, for example, involves an enormous amount of air travel, and air travel is utterly unsustainable and has to be phased out. In the sustainability politics research seminar series that I run as part of the so-called Sustainability Politics Research Lab here at Brunel, last week I invited Julian Allwood, an engineer from Cambridge, to speak. He runs the UK Fires research program, which has done a lot of work on Britain's decarbonisation possibilities. And their argument is that aviation has to be really completely phased out by 2050 and basically ended by 2030, apart from keeping open just 2 airports in Britain, Glasgow and Heathrow by then. If our carbon targets are going to be achieved in a way that the relatively safe figure of 1.5 Celsius is manageable, if that sort of pace of action were generalized on the universal scale. So for an industry such as ours, we simply have to, we've been heavily incentivized to travel by air to conferences all over the world, to these glamorous gigs that we get offered, get invited to speak at, and so on. But I think we need to rapidly flip that around and disincentivize aviation in this industry. Just to give you one concrete example, obviously this is a climate emergency, so all of us and all institutions need to be acting rapidly on all fronts. Apologies that this was less about my research, but that's widely available, and more took the form of a rant. But I hope it's at least provoked some thought. Thanks very much.
Great, thanks very much, Gareth. So we now move on to our next speaker, Devanshi Chanchani. So Gareth, if you could undo your slide.
Oh, I'm sorry, yeah. How do I, just a minute. Thank you.
Lovely, thanks very much. So,
are you able to see my screen?
Not yet. Ah, yeah, yes, all good. All good.
Okay, great.
Over to you, Devanshi.
Right. So, yeah, it's great to be able to present my work here. I'm presenting a paper that is co-authored by my colleague, Patrick Oskarsson from the Swedish University of Agricultural Sciences. This is based on our primary research, which is actually ongoing in Chhattisgarh in central India. That's the state highlighted in red, and it's research that's part of a larger project looking at citizen science, air pollution, and health in India. And this the research that I'm presenting is on a paper on cooking fuels and the difficulties in making the transition to cleaner cooking fuels, which has recently been published in the journal Energy Research and Social Sciences. So Chhattisgarh, as you can see from the photographs, is located in central India, and this is part of central India's coal belt, which is, as many people would know, India is so the central Indian coal belt is responsible for producing most of the coal in the country, and remains the primary source of electricity production in India. And more than 2/3, in fact, almost 75% of India's energy production continues to depend on coal. And here, these are regions with vast open coal mines and power plants and coal-fired industry, such as steel plants, which you can see in the background there. And there remain very, very significant challenges to weaning India away from coal, because a range of interests have kind of kept India dependent on coal. And of course, there's a huge and growing energy demand within India, which is not quite, and while renewable energy sources are increasing, such as solar and wind, these are really not keeping up with the kinds of demands that we have in India, and therefore coal continues to expand. We have continue to have newer coal mines, new clearances for new coal-based power plants and industry, and it does not really look like we're going to be able to move away from this. So this photograph is really just from the railway station in Chhattisgarh, and yeah, this is the transport of coal from the mines to several parts of the country. And of course, there's a huge livelihood reliance on coal, both formal and informal. And again, of course, there's a big nexus between industry and the government. And then within all of this, you have, again, coal from a climate perspective, also the use of coal as a cooking fuel amongst the use of other solid fuels. So from a climate change and environmental health perspective, activists have often argued that the focus remain on industry and electricity production rather than look at the use of coal and other solid fuels in domestic use. But we know, of course, that there are huge health implications of solid fuel use, and coal remains amongst the most polluting, both for the environment and with the most severe health consequences. So this research is really about some of the challenges in making the transitions to clean fuels in cooking and other domestic uses. So this is a picture from one of our field. These are some photographs from our field sites where we've been doing the research. So the research is primarily based on qualitative methods to try and understand what are some of the challenges to making the shift away from coal and other solid fuels to cleaner fuels. And these are pictures from every morning and evening. The whole basti or the habitation is engulfed in smoke. Yeah, and we have these Atmos monitors which capture PM 2.5 levels, and they really max out, as you can see, morning, evening, they really, it's beyond 1,000, and the measures really kind of max out. The monitors are not able to capture the levels of pollution in these micro environments. So, like, from the perspective of, why is clean cooking important? Of course, from the perspective of the climate and shift away from solid fuels, and particularly important from a health perspective for women and children who are most exposed to air pollution in these environments. And there have been several decades of research and intervention to shift, to make a shift to clean fuels. One, to make a shift to clean fuels, and second, to really come up with to better design stoves that vent smoke away from kitchens, but mostly over 4 decades, there have been massive challenges in making the shift to cleaner fuels. And here's where we feel that, perhaps there's not been enough qualitative research to understand some of the challenges. And here's where we think that some of what we are finding is interesting. So what we found is that in Chhattisgarh, we've taken the perspective that taking a view of looking at cooking fuels as produced is really important, because while fuels like firewood and so on may be available to be used, it's only a whole lot of factors go into whether or not they can actually be available as fuels. So we've taken in this paper a view of cooking fuels as being produced, and it's mainly women and children women primarily, who are involved in making the commonly available fuels available to be used, producing those fuels to be used. And you can see here, like coal is commonly collected from the coal lines. Here you see cow dung. Similarly, very, very innovative ways of mixing coal dust with clay to produce these little laddus or cakes, which are then combined with a variety of fuels to be used. And then, of course, here you have the gas cylinders as well. So we find that a range, this is really not quite understood, the range of cooking fuels and strategies that communities use to make available fuels. And some of our domestic fuels, and just very quickly going over some of our findings, we find that there's a very, very, very fluid scenario of domestic fuel use, fluctuating movements along the energy ladder. So there's this whole idea that communities would move up the energy ladder to move to cleaner fuels with improvements in income, but we find with increase in income. But we find that there are a whole lot of variables that influence this movement. And there's a jugaadu, the word that we use here, a colloquial term for workaround or hack approach to domestic fuels. And so depending, of course, income is a huge factor, but so is family makeup. So for instance, you find that larger family sizes are families that have that are large often have female labor to go out there and use other solid fuels or make those coal cakes and so on, and go out and collect the fuel wood, which sometimes smaller families are not able to do. So they spend a much larger proportion of their family income on gas. So there are a whole range of variables that influence the kinds of fuels that families use. And then there's a whole aspect of migrants versus long-term residents. So from a policy perspective, these things I think are not entirely understood. So for instance, migrants find it really difficult to come up with the paperwork for gas, even though they are often not in a position to seek out coal or other fuels in these locations, given that often they are just a couple that's come in from a rural area to a city. So and then again, there's a whole big difference between new and old habitations. Newer habitations again make the shift much faster, whereas older habitations don't. So there are all of these factors that really are not entirely understood. And then, of course, we find that income clearly matters a lot. In fact, households classify themselves in terms of the household fuel they use. So we are the Bhusa Sigri people or the gas people. They actually classify themselves in terms of the fuels they use. Then we found few, if any, cultural barriers. A lot of research in rural India has found a whole lot of cultural barriers in making shifts to cleaner fuels. Here we found that LPG was very much aspirational and desirable. And also our research kind of points to some methodological implications for studying expenditure on domestic fuel use, because we found a very, very fluid situation from month to month to month in terms of how households were supplying their domestic fuels. And we think it's really important to look longer term to examine household expenditure on domestic fuels. And again, we found that pollution is really a very, very marginal consideration. And most families, understand that it's very polluting, but would rather use that than use coal or other solid fuels because there's very few other ways of making savings. But again, it's not the only income is not the only criteria here. And then there's this, so just coming to towards the end of my presentation, we have this policy in India called the PM's Ujjwala Yojana, or the brightness scheme, which seeks to aid the transition to cooking gas and seeks to basically expand the net of users by giving them a connection for cooking gas. But we find that there are, like, while the net of users has expanded, there's the Ujjwala gas users often don't refill their gas cylinder. So while they might have a gas connection, they continue to not refill it. And then here we see that unaffordability is a huge factor. And again, I mean, from a policy perspective, something that's really could be interesting and I think is also going to be tried now is we found that the size of the refill cylinder, so it's a 14 kg cylinder, but that the upfront cost for that is very, very high for people to be able to refill it. But if you did have a smaller cylinder, it looks like a smaller sized refill cylinder, so maybe 5 kgs, our research was indicating that there might be much more scope for people to come up with that much, with a smaller sum of money to refill their cylinders more frequently. Yeah, so basically, you know, the implications of this research are to really acknowledge the messy picture of energy transitions for the urban precariat and understand and really focus on qualitative methods and longer term perspectives in understanding the household energy mix. So with that, thank you. And that's just a link to the paper that we have out on this work. Thank you.
Great. Thanks very much, Devanshi. So our next speaker is Sotirios Argyroudis. So Sotirios, over to you. Devanshi, could you take the slides off?
Sure, yes.
Thanks.
Yeah, thank you, Justin. Hello, everyone. Just to share my screen. So can you see my screen?
Yeah.
Yeah. So yeah, my presentation and my topic is around the resilience of transport infrastructure exposed to climatic hazards and climate change effects. So as we all know, transport infrastructure is exposed to natural hazards, and this is nowadays exacerbated by climate change effects. For example, we have floods in series over time, or landslides that are triggered by intense rainfalls. And this was proven to have severe consequences on our economy and our societies. So there are many examples from the UK and from all over the world of such impacts on transport and critical infrastructure, for example, railways or bridges that have been failed due to flood events or landslides, or even power substations which were flooded because of intense rainfall. So the cost of the disruption because of climate change hazards can be very high. For example, in the UK, it was estimated that the annual cost of disruption because of floods in road infrastructure only can be in the order of 200 million pounds by 2080s. And this is an example of a bridge closure, the Queen's Ferry crossing in February 2020, which closed due to falling ice on the deck. And in this study, we estimated what was the indirect losses because of the traffic diversion during the 36 hours of closure of this bridge. And our estimation was that this losses due to traffic diversion was more than 3.5 million pounds per 24 hours per day. The impacts of, it's important to understand the impacts of climatic hazards on transport infrastructure. And in this respect, we have introduced this system of assets concept where different assets are exposed to different hazards, and at the same time the assets are interactive to each other, so it's interdependent assets, and the consequences in case of disasters can be even higher because of these interdependencies. And then different hazards may have different impacts on the infrastructure. For example, extreme temperatures due to climate change may have minor damage on a bridge, but the loss and the economic impact may be very high. And this is the example of Queen's Ferry crossing that we have seen just before. So there are challenges and gaps in climate resilience of transport infrastructure, and it's an urgent need to shift the current practice and thinking on infrastructure planning, design, and operation, considering climate change effects. So we urgently need practical methods to define and measure climate-aware resilience. Also, simulation techniques for interdependent systems, for example, transport and energy networks, including also the modeling of climate change scenarios and stress testing to assess potential impacts. Also to produce climate change vulnerability and risk assessment, and to show how these risks are linked and may change over time, also because of climate change effects. And finally, to identify actionable adaptation measures and to develop efficient approaches for communication of the risks with the stakeholders. So this is a general representation of resilience for infrastructure. This graph shows in the vertical axis the functionality of the system, and this is correlated with time in the horizontal axis. So the functionality may be reduced because of external stressors due to climatic hazards and climate change effects, and then depends on how robust is the infrastructure and how much of these stressors may absorb, and also how quickly the infrastructure can recover after an incident. So this is the resilience-based approach, and this green area in this graph represents the losses because of the external stressors, while the yellow area represents the resilience of the infrastructure. So this is a, let's say, holistic design and assessment of critical infrastructure, which is currently included in the priorities of stakeholders and global organizations in planning and adaptation to climate change. And some examples of recent research on this topic. So this is a simplified version of a climate resilience assessment framework. I'm not going into details, just to highlight what we need in order to assess the resilience of infrastructure. We need to know the hazards and the intensity measures. For example, what is the expected flow depth, or the water discharge, or the scour depth in a river crossing bridge. Also, we need models to assess vulnerabilities. So essentially to correlate the intensity measure with damage, and also models to assess and quantify the recovery. So how quickly different damages can be restored, and this combining all this will help us to estimate and quantify the resilience of the system. So some examples of how we model the vulnerability of critical transport infrastructure, in this case, a highway embankment, which is exposed to different water levels. So through this modeling, we can understand possible damages and failures because of these flood effects, which are exacerbated due to climate change, and we can produce models which correlate damage with water level intensity. Similarly, for other assets like bridges, through these advanced numerical models, we can simulate different hazard effects, for example, hydraulic forces or scar hole formation on the foundation of the bridge, in order to estimate the performance of the asset and produce models like that, where for the different components a bridge, we can correlate the intensity measure of the hazard with the probability of damage. So once we have this, we can then also make estimations of how quickly this damage can be restored. And this is another recent publication where, based on elicitation from experts, we collected this data in order to express the rapidity of the recovery in case of flood damaged bridges. And based on these models, we can estimate the resilience of an asset alone, and then proceed with the resilience on an infrastructure level. So we may have tunnels, bridges, or highways with different vulnerabilities, different resiliencies, and combining all this at the end on a national scale, we can prioritize the critical infrastructure, also by considering other aspects like environmental impacts or businesses interruption. And this is very useful tools for stakeholders and decision makers who make decisions for adaptation measures and allocation of their resources against climate change. Finally, something that we are currently working is how we can use data from digital technologies in order to enhance climate resilience of transport infrastructure. So this vast of information that is currently available from satellite images, drones, or other monitoring systems can be used to update and improve our models for the functionality, fragility, and resilience assessment of transport infrastructure. So to conclude this presentation, it's important to develop tools and metrics for the resilience assessment of infrastructure exposed to climate change effects, and also produce reliable risk assessments for network owners and operators in order to quantify the performance and losses that is expected from different climate change scenarios. And in this way, we can prioritize and inform interventions both proactively before occurrences of hazards, but also reactively after the occurrence of a hazard event. And this aligned with some sustainability development goals on disaster risk reduction and infrastructure resilience. So I'm stopping here, and thank you for your attention.
Great, thank you very much. So we now move on to our fourth and final paper for this session from Christina Webb. Christina, over to you.
Hello, good afternoon, everyone. Let me just share my PowerPoint. Cool. Is everyone able to hear me and see the PowerPoint?
Yes.
Lovely. So my name is Christina Webb, and I'm a doctoral researcher at Brunel. I get the opportunity today to share with you my exciting topic of sustainable materials and all the recent developments that's actually been happening. So the effect that human activity actually has on the environment is pretty well documented at this point. There's all these reports coming out, there's all these massive conferences that world leaders are attending, and it's constantly in the news as well, like all over the world. These issues such as global warming and climate change, also the large volume of waste that is accumulating within the oceans and within landfill, also leading to pollution. So gradually over the last few decades, with the sudden consumption of waste and products, mostly related to overpopulation and this not over demand on sustainability and the emphasis that should be placed, the world's global temperature is actually going up with climate change and global warming, and also the emissions that are released through all the products and materials that we are making. These are causing mass problems around the world and should need to be addressed very soon. The need for sustainability is particularly important now, as in, for example, in 2019, the UN General Assembly predicted that if change doesn't happen within the next 10 years, that the environmental impact we're actually having could become irreversible for the future generations. So the first question actually is, well, how do you assess whether your product or service, how much of an environmental impact it actually has? Because you need that baseline for future improvements to be compared to see if you're actually making a difference. One possible approach to assess this is known as a life cycle assessment, and this is what I use in my research. So a life cycle assessment is a systematic approach where you go through the life cycle stages throughout the product or service. You see what materials and energy costs are going into actually making the product, and then also what emissions are coming off and how that affects the external environment. So while running these LCAs using software such as Simapro or Gabi, you are then able to identify which life cycle stage has a very high environmental impact, and that helps you focus where you should put the effort and improvements in to make the best benefit overall. Now, I found while running my LCAs that the materials input is particularly impactful. So this is where my research really gets interesting, because this is where you can see where sustainable materials and the exciting different grades of materials can be incorporated into products to reduce its environmental impact in quite a substantial way, and for many different reasons as well. So the area I work in is the area of bioplastics. This is a type of sustainable material. You may be asking what actually defines what a bioplastic actually is. So I have found it best to describe it in two classifications. Bioplastics can be either sustainably sourced or sustainably disposed of. So I'll start with the sustainable sources. So the traditional petrochemical plastics are derived from fossil fuels, which you have probably heard are depleting, and also have a lot of CO2 emissions associated with the burning of these fuels. So one possible approach is to actually make plastics that have similar mechanical properties and can be used in the same way as traditional plastics, but that actually derive from renewable resources. One of my favorites here that I particularly think is a very promising future in is polylactic acid, which is made from the fermentation of crops such as wheat and corn. Another approach is having a low embodied energy. So the energy and the input that has gone into a material to make it what it is known as that material's embodied energy. So some materials actually require a lower input cost than other materials. A good example of this would actually be to compare polypropylene with a rubber. So polypropylene is made from fossil fuels, but the actual electricity going into like cracking the fossil fuels and then making those plastics, and also the potential for the polypropylene to be recycled end of life, is a lot lower compared to something like rubbers. So that's also to be considered of like a lower environmentally impactful, despite it's a fossil fuel, it's still lower energy requirements. It is also possible to make materials from recycled content, which helps to keep material in the what is sometimes termed as a circular economy of materials within industry. So then the other classification for bioplastics would be its end of life. So there are actually four main types, or I like to nicely sum it up in four main types of end of life disposal after plastics have been used. The main ones that are currently used are actually landfill and incineration. These are because it's actually most materials can be placed into landfill or incinerated, but then this leads to problems such as a large accumulation of waste, taking up a large volume of space as well. This affecting the wildlife around the landfill. Also, the incineration can give off harmful emissions when you actually burn the materials. So this is why I am trying to focus on plastics that are easily recyclable, or something like biodegradable or compostable, which is the treatment via biological processes. It was predicted that since 2015, 6,300 metric tons of plastic waste has been generated, with only 9% being recyclable. This is obviously on the rise, but with the fact that a lot of these plastics, such as polypropylene, are like 100% recycled, this should be a lot higher. So that is why it's important to look at these bioplastics that have the possibility to be more easily recyclable, but then also look at the infrastructures in place to see where these connections can be made to reduce the accumulation of waste and to save that initial energy placed into making these materials. Yeah. So as I said before, I am a massive fan of PLA, and also in the top left-hand corner, you have starch as well. You may actually have started to see in large corporations such as McDonald's, Wenzel's, they're starting to create their cups and their lids out of PLA. So, because one of the main problems that has been with the pickup of sustainable materials is actually the infrastructure in place to largely produce these materials so that they become cheaper overall, so the economies of demand. So it's quite exciting that, especially with all the news around sustainability, corporations have started to see the financial benefits of largely producing using these bioplastics. So this actually comes nicely into what I personally find the most impactful part of my research, is where I'm looking into the advantages and disadvantages of the bioplastics already on the market and some of those emerging ones that are developing and coming out from labs as well, then trying to see the practical implications of these to see if they can be created on a large scale. So some of my work also looks into whether you can, because say you were to take starch, which would have one of its main disadvantages is its slightly lower mechanical properties that doesn't help it compete with conventional plastics. You can actually create blends from these starch by mixing it with other types of bioplastics. So my research also looks into possible blends that you can do for mixing these together to make it a more attractive option to industry. Yeah. So also a final part that I'll just kind of conclude on is that there are bioplastics out there. There are ones that have the mechanical properties that traditional plastics do. It's just different ones have different disadvantages. So some are perfect, except they're very costly because they're not being produced on a large scale. So the main key part of my research is actually collaboration, bringing in the innovators and the researchers that come up with these great new products, but then introducing those to the industry manufacturers and trying to work with the actual injection molding machines and extrusion molding to try and make it work on a large scale so that it can become accessible to the consumer on a large basis. Yeah, cool. Thank you very much.
Great, thank you, Christina. Because the speakers have stuck to time so wonderfully, we have plenty of time for Q&A. Tom has asked that you could raise your hand if you have a question you'd like to ask. Ariana.
Oh, hi. That was a very nice presentation. Thank you. Just one question in terms of the life cycle. Are you thinking of greenhouse gas production as a result of biodegradation of some of these plastics? So the end of their life?
Yeah, that's a brilliant question. So that is actually why I think life cycle assessments, even though in principle, they are very straightforward, you've got your inputs and your outputs, but in actual practice can take a lot of work. So you are considering end of life when you have these plastics that degrade, or even if it comes from renewable sources, the CO2 that is actually taken in by the crops, they're all considered as well. At the end of the day, your life cycle assessment is going to be just as accurate and reliable as the information you're inputting into it. So the more information you can get about this end of life and actually the input, the better and more accurate your outcome is going to be. Yeah, I hope that answers your question. Feel free to.
Thank you.
Okay. Well, while we're waiting for other questions to come in, I have a question which I'd like each of the panel to answer, and it's inspired by a point that Gareth made at the end of his presentation about disincentivizing air travel, which is a very interesting idea. So I wonder if you think that the steps that you've identified that need to be taken are best served by market solutions or prohibition solutions, and they could be a combination of the two. But perhaps you could reflect on that. Gareth, could I start with you?
Certainly. Thanks for the question. Well, I mean, my answer was fairly implicit in my contribution. I think the sorts of solutions, I mean, I indicated at the end of my contribution that I see us facing such a degree of climate emergency that every solution we can think of has to be thrown at the problem at the same time. So if somebody wants to pursue market solutions involving carbon price, you know, go for it. I don't see that solution as having been particularly effective. If we look at the carbon trading that we've seen so far, my go-to solution is to campaign, build social movements, try and encourage wider layers of people to become invested in this issue, which is so vital for their future and above all, their grandchildren's futures. And certainly forms of prohibition, I think, are necessary. I mean, personally, I think we should move towards rationing of certain things like flights, you know. I think in terms of aviation, I think there should be pressure from government on businesses to permit more flexible working time and vacation solutions for their employees, such that you can take a ship across the Atlantic, do some work for a week while you're sitting on it, and spend a month there, you know, touring around it by train, giving your papers or whatever as an academic you're over there to do, and you know, engage with your workplace online if that's possible for those weeks that you're away. Then I think there needs to be radical thinking along those sorts of lines. Certainly, I would advocate prohibitions, although of course, obviously, that has to fly politically as well, and I recognise that can be difficult.
Okay, thank you, Devanshi.
I would say, I mean, for the context that my research is based in, where there's such, I mean, with respect to domestic fuels, where there's such a huge dependence on solid fuels, prohibition is really not likely to work. Also because people are, I mean, because of the income and income factor for a very large majority of the population. I think we really do need to kind of tailor policy market solutions better. I think that's also going to require a lot of subsidy, including better, of course, more technological innovations and making those more widely available. But I think to make a substantial shift is going to require some subsidy.
Yeah, no, I mean, yeah.
Yeah.
Okay, thanks, Sartorius.
Yes, so I was thinking that the recent pandemic due to COVID-19 provides a good example of how, for example, flexible working conditions can reduce emissions. So there were these satellite images of air pollution in China and India during the lockdown, and it was impressive how much the pollution was reduced because of lower emissions due to reduced transportation and traveling. Of course, the economic impact was severe, but at the same time, this was an experience of how, for example, flexible working conditions can reduce the emissions. So we can learn a lot from this situation.
Okay, thank you. And Christina.
Great question, actually, because in my area of research with the materials, a lot of it is actually connected to the large production by the manufacturing companies. And a lot of these businesses are actually based around whether it is a financially good option. So when I'm looking at these materials, I do need to consider whether they are whether they can be mass produced in a way that is not only beneficial to the planet, but also to the company. Because when the company starts seeing that it isn't actually too much more expensive and they can get a lot of advertising benefits from the consumers, environmental conscience, I guess, and they start to sell more, it actually becomes profitable by them. So you don't even need to force, because we all know governmental changes take a while and take a lot of work. So when the businesses come to the actual researchers being like, this is this is cost effective for us, we really want to put this in place as quick as possible, that's when I found that change is very, very fast. And it's actually shown that in some of the work I've done, that the governmental enforcement, a good example for this would actually be phthalates in polyvinyl chloride. They were shown to be terrible for the environment, and the government actually put restrictions on these phthalates to be used as a plasticizer. Within a few years, these phthalates have been practically phased out. And when a consumer goes to buy PVC, if it says it's still got phthalates in, they just won't buy from them because they realize that the government has put money, cost on it to say this is terrible for you. And then when the consumers themselves are like, if you don't change, we're not going to buy it, the businesses suddenly pick up very, very quickly. So also there's initiatives the governments have done about carbon offsetting, saying if you don't recycle this amount of your product, then you have to pay money as well. And then they suddenly see the dollar signs with all that. And that's where I found the change to be most efficient. So, yeah.
Okay, thank you. So we've got opportunity for maybe one or two more questions. If anybody has them, raise your hand or put something in the chat if you do. Tom, is there anyone I can't see?
Not at the moment, Justin.
No. Okay, well, if there are no further questions, I think it's a good opportunity to take a quick break before the next session, which will be introduced by Professor Jeff Rogers. I'd like to thank all four speakers for their fantastic presentations and for sticking to time, and for also engaging with the questions from the floor. We've had a question from Genevieve. Could we have the slides? I'm sure Tom will be able to sort that out, no problem at all. So we'll have a short break, stay online, and then Jeff will resume the session at 1 p.m. So thanks everybody, and thanks especially to the speakers. Cheerio.
Thank you.
Thank you.
Good afternoon, or good lunchtime, everybody, and welcome to the next session in the Climate Change Symposium. So the next speaker is Shona Patterson from the Business School, who is going to talk about risk, inequality, and knowledge exchange, bridging the climate chasm. So welcome. Shona, are you in a position to share?
Absolutely, sir.
Go ahead, then. Thanks very much.
There we go. Hopefully you can see that.
I can't.
No.
Okay.
Which probably means it's the same for everybody else.
Let me just see.
Right, it started now. Yeah, that's it. So just into full screen it.
Yeah.
Yeah, there you go.
Can you see the full screen, or can you see the note?
We can see your notes as well.
Okay, let's just Let's just do that instead then.
That's absolutely perfect. Thanks. Yep.
Hang on. No, it's not moving. Just 1 second, sorry. Let's see if I can stop sharing. I do so hate this. I promise I will get there. All my screen is completely duplicated and I can't do anything with it.
This is the academic equivalent of waiting for the overhead projector.
Yes, absolutely. You know.
For those that can remember such things. Or indeed sending someone to go fetch a new bulb. Right, go on.
Okay, we'll try it. We'll try it from here. We'll see what happens. Thank you. Wow, I still seem to have sort of screen sharing at the top. All sorts of weird things, but we'll try it. So thank you very much for the opportunity to talk today. I would like to take perhaps maybe the slightly unsexy idea of looking at this from a policy perspective rather than anything else. So you'll have to bear with me at some level. And we are all very aware that climate change is having sort of very dramatic impacts and will continue to have very dramatic impacts on sort of all social, biophysical, and economic landscapes. And so most of my work that I've been doing recently has really looked at 3 different frameworks through which I really can't move this. 3 different frameworks of governance, and this is sort of climate risk assessments, climate change adaptation, and then really looking at disaster risk reduction as well. And these 3 different frameworks are sort of bounded, if you like, by a series of, wow, this is not going well. By a series of different international conventions, different sort of initiatives, be these sort of Sendai Framework for Disaster Risk Reduction, UN Agenda 2030, and other examples like the Convention of Biological Diversity and the New Urban Agenda also tend to frame these different sets of governance issues that we look at in terms of climate change. So I'd like to sort of take a step back. I think we often get sort of stuck on definitions and what definitions might mean. In terms of climate risk, the Intergovernmental Panel on Climate Change really defines or derives risk from some of the magnitude of the hazard, sort of the relative importance of stuff, and then the vulnerability of that stuff. And hopefully this sort of diagram is not new to lots of you. It's been used in IPCC reports for several years now, but it really allows the definition of risk to come about in terms of the potential for consequences where something of a value is at stake and the outcome is uncertain. And we really start to look at climate risk through this sort of framework where there's a likelihood and an impact associated with each risk that determines urgency, and then we can prioritize based on that urgency. And urgency really is a sort of a measure that has come in through the UK climate change risk assessment process, certainly in CCRA2, and then also in the 3rd one that will be published recently, pretty soon. So adaptation, what do we mean in terms of adaptation? Again, IPCC is looking at this as sort of the process of adjustment to actual or expected climate change. We see this in human and in natural systems. And we also see this idea of adaptation being either incremental or transformative. So again, I do want to sort of mention in passing, and I know that adaptation and mitigation often work in tandem, but it's really much harder to perhaps maybe get funding for adaptation because there's no revenue stream attached to it. Adaptation is much more about protecting what we have now and possibly in the future, but mitigation, there's often there's something you can sell, there's jobs attached to it. So adaptation sort of ends up being much less engaged with, I think is probably the correct word there. But obviously, again, if you look at sort of the frameworks that we use, you identify options, prioritize, plan, and then take action. And there is this monitoring process involved with it as well. So to disaster risk reduction, and again, these are sort of the three governance frameworks that I'm working with a lot. Disaster is a social construction. I want to be very clear about this. Disaster does not happen unless people and cities are vulnerable due to marginalization, discrimination, and inequitable access to resources and knowledge. There are no such things as natural disasters. I cannot stress this enough. And we really start to think about sort of the framework that's associated with disaster risk reduction being linked through this preparation, response, recovery, and then an evaluation process. So it's relatively easy to think about these different frameworks, and you can see there's at least some avenues for perhaps maybe enhancing the policy cohesion and how this policy cohesion between these three frameworks could perhaps maybe bridge these gaps. And this is the work that I've really been involved with recently, and trying to understand what can be learned and what can be achieved from these frameworks. And this has resulted in a partnership and a book that will be launched on the 3rd of November, I believe it is, really trying to understand through a series of case studies, as well as sort of theoretical conversation and discussion around creating resilient futures. So there is this disconnect, as I mentioned, between these frameworks. And you see this disconnect both in terms of language, scale, scope, legal status, and all these ideas really do pose a considerable challenge to the evolution of that a more integrated approach to risk management, especially with the climate sphere. So we spent quite a lot of time looking at sort of different ways and different impacts of increasing that integrated approach. And you can start to think about racial integration and sort of the effects that this would have, positive effects that it would have in terms of maximizing efficiency and reducing human and technical financial resource use. You can also think about this in terms of technical integration and sort of the sharing of expertise. But this really does sort of simplify quite a complex landscape that these three frameworks exist in. Often, if you look at disaster risk reduction, it's usually housed within ministries in different countries. There's a disaster management or an emergency management ministry. It very rarely is a climate risk or a climate adaptation ministry. That tends to be sort of subsumed by environmental agencies or departments. And often you don't see any communication between these different components. There are very few there are some without a shadow of a doubt. There are very few environmental agencies that really will spend time discussing disaster risk reduction with either the sort of governmental or non-governmental actors or the humanitarian actors that work in this space. So it's not quite as simple as saying, oh, we should just join it all up and we'll all be done and we can move on. And I do want to recognize that as quite a, as I say, quite a complex landscape. But if we start to put sort of this idea of risk being very central within this concept and start from a climate risk assessment perspective, then we can really think about how we might be able to increase the integration between these different frameworks, acknowledging that there are a series of sort of feedback loops, and this is an iterative cycle of action. But really placing risk at the center and trying to define what that risk might be allows us to think about sort of adaptation in slightly different way. And this is sort of, as I said, sort of the basis of the policy work that we've been doing. And in that case, I really want to think about risk more closely. Risk, globally, we create risk much faster than we know how to deal with it. That's sort of really not debatable at this stage. But risk is also an ever-moving social construct that is sort of reimagined and reinvented by society over time as our values and our norms change. We see this throughout history, we see it across cultures. Risk is quite different depending on where we are. And it also is based on different value and different knowledge systems. This means that risk is neither fixed or neutral. So we produce, especially in this country, we produce these very nice risk reports. I'm sure some people have seen the climate change risk assessments, and there are tables and tables of risk, but usually they don't include social values, they don't include equity, they don't include this idea of socializing and social construct within risk. And often the second the report is produced, it's obsolete. And so most of what I've been doing recently is really trying to think about risk and this sort of this socialized perspective of risk, and accept that while climate change and natural variability impact risk, you also have social modifiers that change the concept of risk. And this really brings in this idea of social functioning, governance, and injustice. And most of the work that we're thinking about now is how to pass risk through this lens of equity in order to be able to figure out what the acceptability of risk is, depending on where you are, depending on your culture, depending on your knowledge system. And this centers equity within the whole conversation around risk. And I think this is a really important thing as we start to recognize what COVID has, in theory, perhaps maybe taught us around inequity and how different cultures and different communities are really impacted by the same risk in many, many different ways. So should we start to ensure that equity becomes the central component of all the work that we're really starting to do? And that basically all the fun diagrams that I have. I'm very happy to discuss risk and climate risk in any way that anybody wishes to.
Thanks, Shona. I mean, I would say academics have been studying perceptions of risk since academia began, but even at Brunel, but I guess they haven't been thinking about climate emergency and risk, which almost certainly would introduce a new dimension into that academic literature and thinking, I'm guessing.
Absolutely.
Yeah, that's right. Yeah, I mean, we also used to do quite a bit of that in our sociology department for a while, but certainly before anybody had ever uttered the word about environmental disaster or climate emergency. Would anybody like to ask a question briefly, or we'll move on to Meredith? Go on.
Thanks, Jeff. Thanks, Shona. Sorry, I can't work out how to put my hand up on Zoom. Oh, I see reactions, right? Anyway, Shona, it's not a question, but I just want to thank you so much for emphasising that there is no such thing as a natural disaster. I mean, even with COVID, we've got people still talking about it as a natural disaster. And I really, really love that you've brought that to the forefront. And partly because, of course, it explains how community concerns, social concerns, economic concerns are what create disasters in context of something natural, you know. So I just wanted to thank you for that. Really great talk, loved it.
Pleasure, and thank you for bringing up I mean, this is my soapbox. I do love a good soapbox around no natural disasters, and I think it really allows lots of actors to sort of avoid responsibility if we start talking about natural disasters. Oh, it's an act of God. No, it's not an act of God that we're still building houses on floodplains and then being surprised that they're flooded. That we're not complying with building codes and then being surprised that tower buildings go up in smoke. This is the concept that really behind the no natural disasters discussion, and I would highly encourage everybody to at least have a look at the literature that's associated with that. And the more that we can change the language, which becomes so important, then the better off we are. So thank you.
Right, I'll just take, thanks, Shona. Hemina, one last question, if you're brief, please, because you're taking time out of your talk.
Definitely. Yeah, I will give. No, I just wanted to, thanks, Shona, and ask you, or maybe if you could explain like how has been the process to try to change this sort of concepts, as well as integrated these social aspects in this field, especially, I mean, I am not an expert of that, so it will be interesting to know the difficulties and the approaches that you have taken. Thank you.
Sure. I mean, trying to bring together and integrate large pieces of policy is certainly not an easy adventure. And I think sort of 2015 really offered a tremendous sense of optimism around this, that a lot of this work has sort of been building on since then, because we had UN Agenda 2030 and the Sustainable Development Goals, Sendai, the New Urban Agenda came out in 2016. I mean, this was sort of a massive opportunity at an international level to really start to wrap up some of these conventions. And to be honest, we really haven't got very far. We talk a really good fight, but actually trying to move the needle on policy integration is a really tough thing. And I think, having worked with the International Council for Science and Future Earth Coasts and all these sorts of different actors, I think this is where equity is really starting to resonate. And it becomes a lens through which we can view sort of these big pieces that nobody really knows how to get their hands around, because equity does and is beginning to matter so much more within the concept of the landscape. So it's still very much a work in progress. I mean, you know, all the books we can produce and everything, it doesn't really make a difference. It doesn't move the needle as much as we want. But at least the conversation and the discourse around equity is really starting to become quite central at that sort of very high international convention level. And it will be very interesting. I don't hold out a tremendous amount of optimism for COP. And, you know, as you read more and more about it, I hope I'm wrong. But it will be interesting to see where the next few weeks take us at an international policy level.
Thanks, Shona. Right, let's move on. So, Hemina, you are the next speaker. Do you want to share your screen? Right, and so Hemina Schmidt is the next speaker, and just find your approaches to integrate sustainability in food systems. Hemina. Right, we can see it. That's fine. Perfect. Just need to unmute.
Yeah, perfect. So thank you, Geoff, and thank you everybody for being here today. I think I'm going to move just to save the time. So basically, I would like just to show that I have been working on the food system and basically moving to these drivers that food is actually the core component in development and has been captured in the UN Sustainable Development Goals, but also is part of the connection with culture, economy, society, environment, and more, and politics and everything really. And I think as such, we need to sort of try to integrate the different actors and see the food system as such and avoid these sort of silos. And of course, now we know that how much the food system contribute to the climate crisis. So there are different numbers, but between a quarter and 37% of the greenhouse gas emissions are associated to the food sector, the food system, but also connected with different uses of resources as well as producing different impacts. So we see how these interconnections happen and what are the impacts as well, like benefits to the society from health development and even economy, but also how perhaps the lack of sustainability, like as a core or the basis, has created many impacts and a lot of inequality. So based on these drivers, my work is always applying this sort of life cycle thinking approach, where we try to see the system as such and work on with the different stakeholders and the interaction between them. And as such, I have been working in different aspects. So for example, we look at farming methods and how we can understand what are the emissions coming from this. So from one side, understand the profiling of the environmental impact, social and economic implications of this. For example, in this case, rice, but in general, farming and agriculture. And then also try to understand as a system how we can look for improvement opportunities. So maybe improve these agricultural practices, different use of resources, and sort of work with people in the field. So in this case, with farmers, but also with experts to try to improve this aspect, but always trying to understand the system behind that and not as just one point. So that also connect with perhaps new food production methods. That is something that now has been very much looked after. So for example, we are talking about vertical farmer. In this case, we are looking at aeroponics. And again, trying to understand the system as such, because for example, in this case for vertical farming, there are a lot of pledges or sort of benefit that not always are for one side quantified, but also try to be like put in perspective. So it's not just one answer for everything. It's actually will depend on the context that is being in place and the sort of, in this case, different products and locations and so on and so far. So for looking at aspects, for example, energy use and resources to the practices and the supply chain of these different products where this system will be plugging in, and then understanding what are the practices in the society, we can actually see what will be the benefits. And this also connect with different experts. So it's, again, we are not working from one angle, but trying to combine the different expertises to understand better how we can understand the benefits and actually drawbacks and be aware of those and also find opportunities to improve. And again, like we need to see the food system as part of our health and our like the impact that will produce. Like we, at least in this country, we are facing a big like obesity and a lot of food related problems. So it's actually, we need to combine, we cannot just look after health without understanding also the environment and the resources around, as well as the context of the economy and the culture. So again, like I work with different colleagues, with nutritionists, with data scientists, with people from medicine and from different fields to see how we can understand this sort of sustainable food production and consumption, sustainable diets in a way that is a much more comprehensive than just going for, you know, everybody going vegan because it's good for the environment, but actually there are much more constraints around that needs to be understood. So to avoid these sort of simplistic messages and actually enable a much better understanding of the problem. And again, moving also towards other aspects, like, for example, cooking, how we understand the practices at home, how those little practices can be improved to minimize our impacts and perhaps even have a better health and better understanding of the food that we consume, how we consume it, and how we can make better choices. And that is why also working with people, for example, from social science and behavioral science to understand, for example, cooking practices. So what happened with different food items in different cultures as well. So it's not just about just about what happened in the UK, but what happened in the global system. So if we start digging into, like, we are unpacking all these sort of different aspects around what happened at home, but also what happened in different food supplies, and what happened in different aspects within the food system as part of in this case, we are looking about household in different places. Also how we can learn from different practices in different countries with different cultures. So it's a lot that we need to be integrated and thinking. Similarly with shopping habits, so about like what happened in different places, but also how are the supply chains and what are the opportunities to improve, and again, to share practices. Food waste is also a big problem, but happens in different places and along the supply chain, but also varies depending on the country that we are talking about it. So again, how we can see these differences and how we can learn and share. And also what happened with the future. We are talking about the young generation, children. If we talk about, for example, the new food strategy in the UK, we are talking about also learning about cooking, learning about food, and teaching in schools and integrating all these aspects. So we are not waiting for adults to change, but actually we can have an influence in young generations. And that means that we also need to work together and try to bridge this gap. So how we can connect with society, how we get people involved. And for example, this is a collaborative effort with different researchers, where we get together to put all this research that we have done and try to develop different resources that we can engage, for example, with schools, we can engage with the public, we can do different activities to enable this understanding and enable people to get better choices. So yeah, that's it, I think. Perfect.
Thanks, Hemida. That's very nice, very interesting. I always regretted not spending more time paying attention in domestic science when I was at school. But it would have been more useful in later life if I had only realized.
It's never too late.
No, it's never too late. It may be a little bit too late. That was really interesting. Would anybody like to ask a question? Or it was interesting. There was some overlap with some of the things Manoj was talking about earlier on, amongst other people. There's some of the interesting parallels. No, okay, all right. Thank you very much. If anybody, oh, Ariana, do you want to? Sorry, I saw your hand.
Yeah, I just wanted to thank both actually, Shona and Jimena, for wonderful presentations. But one quick question to Jimena in terms of the cooking practices, because I think Shona very, very clearly highlighted the issue of equity. And I think cooking practices is an availability issue, and whether these domestic tasks, have an equity issue as well, whether it comes from which economy or community you are part of, but also gender related. So is there any view you have on that, or any further exploration you're thinking to do? Thanks, Jimena.
Thank you. So yeah, that is definitely something that we are trying to integrate, working with people that are expert in the field. And actually, for example, this data that I show, we survey in different countries, and it was very interesting how much more male were answering these surveys. And it's because it was, for example, online, and also because are those that have the time to answer this sort of question, while probably more females are like working at home or cooking or doing all the household activities. So we are trying to integrate this in a way that, for example, how we connect with more sustainable food consumption. So how we learn and how we shift these practices. So yeah, that is still something that we need to look after, and colleagues are collaborating with that.
Yeah, I mean, the impact of, say, 20% increase in working from home on food practice could be quite dramatic, really, if more people had time to get in the kitchen.
Exactly.
And different people not traveling to work each day, and that extra time that generates in the UK, where the average journey times, particularly in the south, are very high.
Yeah, but also will be with like how the household activities are shared at home, right? So it could be 20% more burden for those
Yes.
that were already leading those tasks, right? But
Yes.
I think what you touched, Geoff, is interesting, because if you integrate this as part, for example, of the curriculum, then it's not an activity that only your mom used to do, or like the females in your house.
Yes.
It's actually that we all can do, because we have the skills
Yes.
and the understanding. So I think that will go there in particular.
Yeah. Okay. Okay. Thanks, Helena. That's lovely. Thank you very much. That's very interesting. So the next speaker is Valentina Stotechka. I think something. Sorry, I didn't quite get that. That close enough. So I do beg your pardon. And you obviously you want to try and share your screen, and while I read out, just check on your title again. It's the decarbonation of food manufacturing in the food sector. So another focus on food supply chains and food processing.
Good afternoon, everybody, and thanks, Jeff, for introducing me. Actually, the title of my presentation is Decarbonization of Food Manufacturing Sector. There was some confusion with the title, but yes, can you see my screen?
Yes, I can. Yes, it needs full screening, but we can see it.
Can I just let me?
Yeah,
okay.
That's it.
Better,
Perfect.
yeah, okay. So I'm going to discuss about the decarbonization of food manufacturing sector, which is a little bit a broad topic. It's not something quite straightforward that we can just say how we can decarbonize or how we can reduce the greenhouse gas emissions. And overview of my presentation would be, I will go shortly, of course, I can't cover all the topics, but I'm going to talk about the greenhouse gas emissions that are generated from the food sector for the food industry. I'm going to discuss about, I will put an emphasis on food waste issues and energy consumption and improving of the energy efficiency. And I'm going to discuss a little bit about governmental strategies for reducing of greenhouse gas emissions, particularly for the food waste and energy, improving of energy efficiency. And at the end, the strategies for decarbonizing of the food sector. So we'll start with some data, some figures related to the consumption of the generation of the greenhouse gas emissions from the food production. And what we can see that there is a good percentage of the greenhouse gas emissions that comes from the whole production supply sector. Or if we take globally about the global emissions of non-food and foods, we can see that 26% of the food of the greenhouse gas emissions actually comes from the food. And there are different sectors that they are covered in terms of where exactly that greenhouse gas emissions are coming. So we can see that 18% comes from the supply chain sector. 31%, for instance, is coming from the livestock and fisheries. 27% comes from the crop production. 24% also comes from the land use. So it's very important how this is handled within the food supply chain. But when we are talking about the European Union and how much is generated from the food and the drink industry, we can see that 23% of the global global greenhouse gas emissions are actually generated by the agro-food drink industry in the EU, and 28% is actually of the greenhouse gas emissions, which 20 to 30% of those emissions comes with from the UK food supply sector, which estimates an annual cost of 1.5 billion pounds. So in terms of the waste, food waste issue, where do we actually stand? The food waste issue, as Jimena mentioned, is also one of the main problems in food supply chain. And for about 1/3 of the food comes from the human consumption, or around 1.3 billion tons are produced every year, according to the Food and Agriculture Organization. I would here separate them in developing countries and developed nations. We see that they are generating waste from different parts of the food process. For instance, in developing countries, about 40% comes after harvesting and during food processing, while in the developed countries, about 40% comes from retail and consumer level. We have also a good amount of waste, about 4.2 million tons, that is thrown every year. landfills are also a predominant method to employ the developing countries to dispose this waste. And there are also a different risk associated with this method, like, for instance, availability of the land, environmental concerns that they are including also the toxin gases and pathogens. So when we come to evaluation of the waste management practices and how that is managed, there is something very interesting to see that between 1990 and 2020, that has been a very much different approach of how the waste was managed. If we classify the waste in terms of prevention, preparing for use, recycling, other recovery and disposal, we can see that in 1990s the waste was predominantly going to the landfill. But in 2020, that pyramid has been changed, and we can see that much more attention has been paid how the waste could be prevented or reused or recycled. And particularly when we are talking about the food manufacturing, it is possible, if it is possible to be recycled or to be or the plant to be developed, that the waste is not created at all. So that's one of the strategies that UK government has set up to come to some zero waste by 2030 or zero greenhouse gas emissions by 2050, or no waste to go to the landfill. So the expectations for 2030 is actually to go with a zero waste to the landfill, and the majority of the waste to be prevented, to use, for instance, to use less materials in terms of designing of some product or manufacturing, and also to extend the shelf life of the food products in order to reduce the greenhouse gas emissions. There are a number of regulations that have been applied on the UK food industry, and UK was the first country to imply the carbon budget, which is known as the Climate Change Act from 2008. And this is to reduce the greenhouse emissions that industry could emit. So the UK is committed to reduce this energy consumption and water usage by 2032 by 57%. And that started from 2008, so we can see gradually that every year the reduction of greenhouse gas emissions by 25%, for instance, to 2012, 31% to 2017, 37% to 2022, and 51% to 2027 has been in place. And I think we are somewhere here, which is we are complying with the carbon reduction or carbon budget to 2022. This has been very helpful for the food manufacturers and for the food industry. Most of the food industries are taking place in this carbon budget. If they reduce the percentage of the greenhouse gas emissions, they can get some tax relief, or if they don't manage with that, in that case they have some costs to pay. So in terms of acceleration of the green growth, this is something that has been also proposed by the government. There is 25-year environmental plan that has been introduced, and this is also related to the to minimize the damage that has been caused by the natural environment, with reducing and managing the waste in a safely and careful manner, and it provides some kind of double resource productivity, eliminates avoidable waste, and recovering products and materials. And that brings us to a circular economy, where all these strategies are not only reducing the waste or reducing greenhouse gas emissions, but they are also contributing to the reduction of the cost for production, and which is very good for the businesses. The additional support from the government also includes, the government has invested about 99 billion to 2021 innovative technologies. That's something else that we also need to consider. And the government is working towards zero avoidable waste economy by 2050 and by 2030 to avoid any food waste to the landfill. There are a number of new resources and waste strategies to maximize the resource productivity. For instance, how the businesses could understand the avoiding of the food waste, reuse and recycling, and also to understand the benefits of this approach in terms of cost saving, also engaging employees in these strategies, and also to achieve in order to achieve zero carbon emissions. Explores also new data that can support the development of the network of the resource efficiency. There is a need of more collaboration between different food industries because, for instance, if the waste is considered for one of the industries, that could be considered as a raw material for another industry, which happens very often. And to explore also new and innovative ways to manage emissions from the landfill. In terms of the energy consumption, we have, it is estimated that the food chains are responsible for 18% of the UK energy use. In terms of energy consumption could come from many stages of food production, from agriculture, food processing, manufacturing, distribution center, retail, food services, consumption, waste disposal. But it is interesting that approximately 65% of the total energy use is in food industries are consumed in food manufacture and processing. And a huge proportion of this waste, about 36%, is consumed by heating processes, for instance, using of the different boilers, dryers, pre-treatments, coating. So it is important that to consider all these elements, and especially in developing new innovative methods, how to reduce energy consumption or to improve the energy efficiency in order to reduce greenhouse gas emissions. So in summary, the decarbonization of the food sector needs different implementation or development of different strategies for net zero carbon targets by 2050, which are proposed by the government. The UK government should establish a new collaborative approach with the relevant stakeholders and the food industry in order to provide incentives and or some kind of support for the food industry, that they can work on, for instance, clean on different energy solutions, like for instance, use of the renewable energy, solar energy, wind power, or anaerobic digestion, waste to energy, where waste could be used for production of the energy. There are a number of the food manufacturers or food companies who have already applied the anaerobic digesters, and they're using their waste for production of the energy and biogases. Also improvements of the energy efficiency with implementing different ISO strategies like energy management systems, heat waste recovery. The waste management strategies also are also important to develop a good strategy that will be followed in terms of food processing, as we mentioned, for reuse of the waste during food processing, or recycling, or preventing the food waste. Packaging waste is also something that needs attention, and production of more biodegradable packaging. So for all these elements, the investment in the innovative technology is paramount to be able to meet all the carbon targets by 2050. Okay, so that's it. Thanks for your attention. If you have any question.
Thanks, Valentina. It's surprising the supply chain effects aren't greater, really. I would have, if I'd had to guess, I would have thought they were a higher percentage of the total carbon cost, but it is quite small, even with our very long supply chains in the UK. Does anybody like to ask a question? All right, we better keep going then. All right, thank you very much, Valentina. If anybody has a question, please pop it into the chat.
Thank you.
And we can pick up on that. There's some obvious synergies between many of these talks. Maria, so the next speaker, the final speaker of this session is Professor Maria Colacatroni, again from mechanical engineering. And Maria.
Thank you. Yes, I am.
I'll let you read the title. I remember it being long and I can't find it. So I'll let you do it.
Let me try and share it.
There it is.
Can you see it? Yeah, you can see it.
It just needs full screening.
Yeah. Let me see if I can do it. I'm trying.
Yeah,
that's fine. Perfect. Okay, thank you, Jeff, and thanks everybody. So yes, the long title of my presentation is about future and urban weather files to be used for building energy performance modeling. And this work I'm going to present today in the framework, it was done with Agnese Salvati, that she was with us as a research fellow until August, and now she has moved to a position at the Barcelona School of Architecture as a lecturer there. So what is the problem I thought of starting with? First of all, we know that engineers use building thermal simulation tools when designing buildings in order to predict their energy performance during the operation cycle of the building. These tools, they are mandatory to be used in some cases for planning permission, and the predicted energy performance that they give us should be less than values that they are prescribed in the regulation, the target values. When we are modeling the building, the external conditions, the boundary conditions around the building are modeled using what we call weather files, that they simulate usually hourly ambient conditions for the whole year, temperature, humidity, solar radiation, wind, and so on. And these weather files are built using past weather data, usually over 30 years, so that we have a typical file. And they are based on measurements at meteorological stations that they are usually at the airports. And the implication is we use them to predict the performance of buildings in cities. So these weather files, they don't include the characteristics of the urban environment, which modifies the climatic conditions, and especially, as I say here, air temperature and wind. And in addition to that, to the urban modifications, we know that buildings are designed today to last for many, many years, usually 30 years, or in many cases, much longer than that. So we need to look at the impact of these boundary conditions in 30 or 50 years. So when we do these simulations to predict the energy performance of our buildings, then we need to make sure that we use weather files that they represent where these buildings are and the time frame that these are. And what we use, term that we use in building services and energy efficiency buildings is this performance gap, that simulations that we do during the design stage, they are different than what we measure in the field. And in many cases, what weather conditions are used, it could be a contributing factor. Of course, there are many, many other factors that they are responsible for this performance gap. So the motivation of this work is that to examine this overlapping effect of global warming and urban microclimate. And this is about temperature, which we know it's increasing. Solar radiation is not clear what is happening, and wind speed is not clear what is happening, or different things happen in different locations. Up till now, we have a number of methodologies to generate future weather files following the IPCC scenarios, and these are available locally and for worldwide locations. But methodologies that include both future weather and urban microclimate, they are less developed, and this is what we try to do. So what we try to do is to test this methodology to include global and local climate modifications in weather files for urban building energy simulation, and to demonstrate that. So in this diagram here, I have the future weather file, but this has been modified based on data from the airport. But then we look at the urban fabric characteristics, and we modify the future weather file in terms of temperature and in terms of wind. And then we look about solar access as well, and overshadowing, what happens when solar radiation is blocked. And all these characteristics are fed to the simulation engine, which is Energy Plus tool at this case, so that we can predict the urban building thermal performance and the future climatic scenarios. Very little here, I'm not going to read all this, but in order to generate the future weather files for this work, we used a methodology that has been developed by this paper that I have quoted here, and also has been used by the IEA EBC Annex 80 on resilient cooling for buildings, taking data from Eurocodex and according to the ISO standard to assemble these typical meteorological years. And we did that in this study, we did that for the worst scenario, 8.5 of the 5th IPCC assessment report. And we saw the new preliminary assessment that was published in August 2001, and these scenarios, they are still looking the same. So they need to be corrected for local bias by comparing them with local measurements in London Heathrow Airport in our case, and then we generated the data for today and then 50s and 90s. Then we need to take the urban context. We've got here our building, the red block here, among many buildings in the city. So we take the characteristics of our building to put in the simulation engine, but then we need to put what happens around it in terms of building density, building typologies, and also vegetation that will give us the urban heat island effect. But also we need to look how it is surrounded by different buildings in terms of plan, but in terms of elevation, so that we can see the modifications in wind speed and also overshadowing effect or the sky view factor. And then the output is taking into account all these considerations. So just to show an example of how this can be used for an area in London, we took 3 areas: a suburban area, a typical urban area, and a city center area. And here you can see the representation. And then we modify the weather files with how I explained very briefly before. And then we can see here what is the difference in the outside temperature, global horizontal radiation, and wind speed. We can see that the temperature is going up, but solar radiation is reducing and wind speed is reducing as well. So this is for the future, and also what happens in the city itself, it is interesting as well. The urban heat island is more intense in the denser city areas, but it slightly decreases in future scenarios because of the reduction of solar radiation. And we did some comparisons here. So if we look at the wind as well, and again, we looked at the reduction in the different locations, airport, urban, and city, now in the future and in 2090s. And here we can see that in the future, maybe the city's wind environment is less dramatically reduced than today, but this is because wind speed is reduced in general according to predictions in the future. And when we look at solar access as well, of course, it goes without saying that it depends where the space is at the height of the building. And then we have bigger effect on the ground floor, but we have even bigger effect in the city because of the density of the buildings there. And this is my last slide, where I tried to look at what happens in the summer discomfort hours if we use this methodology to look at what will happen in our building. And here what we have the suburban, the urban area, and the city area. And we've got the ground floor, the middle floor, and the top floor in the building. And this graph is for today, this graph is for 2050, and this graph is for 2090. So have I run out of time, Jeff?
If you're summarizing in the next 2 minutes, then that would be perfect.
Yes, I'm summarizing. Actually, this is my last slide. Right. I just need to explain this text here. That we can see that on the ground floor, the urban context reduces the discomfort hours, as we can see here. And then the future climate will determine and decrease in the discomfort. But in the other two floors, and as we go above the building, the urban context in both cases increasing the discomfort hours, and the future climates does the same. And then coming to the beginning of the introduction in this talk is when I was saying that we use the suburban weather files to predict what happens in our building. And we can see here that we predict 14% of the hours will be non-comfortable, not comfortable, while in reality, what will happen, 42% will be because the building is in the city. So using the right boundary conditions, we know it in all the sciences, but using the right boundary conditions is important for building simulation as well. So the conclusion is that the urban context can have a mitigating or amplifying effect on the building overheating, risk associated with climate change, and a correct assessment of the impact. And I'll finish here because I have said it already, these conclusions. So thank you for listening. And this is a paper that you can find some more information if you like.
Thanks, Maria. That's really interesting. So this could both impinge on sort of solar protection and solar energy generation strategies for future buildings. Is that right? You'd be thinking about where you need to put protection to reduce heating, unnecessary heating, but also where you wanted to put panels to generate. Is that part of the thinking?
It is that part of the thinking, because if we would like to put solar panels on the facade of the buildings, for example, looking at how the solar radiation that impacting on them is going to be affected by neighboring buildings, then that's quite important. So it is the generation. And also it is the passive ways that we explore solar radiation, like, solar gains that they come through our windows, that in many cases might be excluded because of the denser building in a city.
Yeah, okay. Thank you. Would anybody else like to ask a quick question? Can't see any hands or anybody waving up their hand physically either. All right, thank you very much, Maria, and to the other three speakers in this session. There was an interesting set of talks, I think. Very, very nice, interesting, different methodologies, and addresses some interesting and important questions. So thank you very much, and thank you very much for keeping to time. Are we going to have a 5-minute break now, Tom?
Right, welcome back. I think time to start the final session. We've got 3 talks in this session, so that either means we finish slightly early or we have lots of time for some questions at the end, whichever way it goes. We'll start, I think I can see all the speakers here, which is good. So we're going to start with Stephen, who's going to talk about sustainable and resilient food systems and indigenous knowledges. So over to you, Stephen.
Sorry, I was muted. Thank you. Let me just bring up my quick slides.
Okay, yeah, that's there. Yeah, just go to presentation.
That's there, right? Yeah, fantastic. Thank you so much for organizing this. Really quite an interesting session, and thanks, Tom, for inviting me as well.
Can you just go to full screen mode with the presentation?
Yes, that's what I'm trying to do now.
Okay, thank you.
Yeah, fantastic. Let me just minimize this. Is it on full screen now?
Yes. Yeah, that's
great. Great. So this is a project that it's a feasibility project we're doing with colleagues from the Open University, the STST, and also a colleague from Brunel University as well. And it's funded by the UK Science Technology Facility, serving through its Food Network initiative. So what is the project about? So what kind of challenges do we intend to address? So this project was developed as a result of the increased challenges small farm holders experience and the threats on indigenous food system and livelihoods in Africa. Increasingly, what we've seen in Africa, there is the continent is currently what we call as a crossroad of agricultural innovation, where we have emerging small-scale agricultural companies, local companies competing with multinational companies for arable lands. And as a result of that, there is some kind of contribution towards increased urban migration, land grabbing, and displacement of subsistence small farm holders. So the consequences of that is that the combination of these two competing challenges lead to kind of put enormous threats on African indigenous knowledge. So this is the knowledge that is held in different cultures and traditions and skills that some of us have experienced when we were growing up, inform the food production and processes across Africa, almost for about 80%. So the idea of this project is to see how do we document this knowledge, right? Because what we're seeing, and there is a risk of this knowledge disappearing. In particular, there is a significant challenge from even the librarians for them to be able to capture and store this knowledge so they'll be able to share it. So our projects draw on data science and citizen science expertise or approaches to develop an interactive open platform where we'll be able to capture, share, and this knowledge to promote learning and to also promote research within the continent. And the knowledge will be used specifically by policymakers to inform decision makings around initiatives that we develop in these rural regions, in regions that really require support. Then also be used by farmers themselves, or to call citizens to citizens instead of peer knowledge, peer-to-peer knowledge sharing. Then also be used by researchers. Okay, so at a much broader level, we believe the research will also inform the way how the UK in particular supports sustainable sort of food production efforts in Africa, because these are powerful knowledge that needs to be captured and integrated into with the scientific knowledge that we have here. So we use two approaches. One is citizen science. Like I said, we also use data science. So from the citizen science perspective, what we did was that we use what we call a participatory sort of video elicitation process, where we gave cameras, mobile cameras to farmers for them to document their experiences, their knowledge, and their everyday practices in terms of food production, food processing, food preservation, as well as food consumption. So we collected that data to help us inform the design of the platform. And the second approach we took was to use citizen science, this analysis. We're using Zooniverse. Zooniverse is FTSC citizens platform where citizens volunteer to help with data analysis, right? Despite the fact that they have no knowledge, right? So what they usually do there is they do some form of what we call a tagging, translation of images, and etc. So we currently develop that platform, and it will be up and running soon. Then the third approach we integrated was to use a co-design where we'll be working with farmers directly. This will be held in November next year. I mean, this year, next month, preferably. Okay, to help us develop the platform as well, along with the information, the data we've already collected. Okay, so at the data level, so we have two data levels here. So this is just an architecture sort of outlook, how the platform is going to look like. So from the end here, we intend to have a data visualization component of that, where you'll be able to know exactly where the specific data is coming from the farmers and their practices around food productions, which other farmers can also learn, or in terms of policy can also understand areas that are most affected. Then we also link the data to the images and videos of those farmers. So if you want to listen directly from the farmer themselves, you'll be able to do that using the platform as well. So this is very critical, particularly in terms of data ownership, also in terms of data knowledge, in terms of also sharing of knowledge across the platform. So another important component of this platform is what we call fair data. So the idea is to make it an open platform where data can be easily accessible. People can easily research about policy, and research and citizens can easily access the data. And also, this data can be interoperable, the system can be interoperable with other existing infrastructure that the ministries or whatever agricultural institutions do have. Then it's also be reusable, which is quite an interesting aspect of the work. That is, you can capture this data and use it. So how we intend to do this, in the citizen sort of participatory co-design workshop, we plan to develop guidelines around that, because one of the major challenges in terms of indigenous knowledge sharing on digital platform is about ownership, right? Because these are knowledge that are held in the citizens' kind of perspective. So when we capture it, we should be able to sort of, suggest in ways that how this ownership is sort of negotiated. So we did plan to develop guidelines around that through the workshop, what's called the ethical guidelines. Okay, so what's the benefits here? So this knowledge, like I said, is very critical, it's very important. It's feasible, it supports over 80% of, close to 80% of citizens in terms of food production, in terms of food consumption. So if we're talking about sustainable food production, so it's a knowledge that we need to capture and ensure that it's accessible, and that's for over a long period of time. So one of the benefits is we intend to facilitate what we call peer-to-peer, farmer-to-farmer learning. This is very critical, in particular in terms of, let's say, for example, how specific farming community cope with climate change adaptation and processes, right? So by having this knowledge, right, other farmers can also learn, and they can also sort of able to implement those strategies to improve their productivity in food processing. The other aspect of is that it sort of kind of creates the link between what they call scientific community and traditional knowledge farming practices. Like I said at the beginning of this presentation, is that there is a competing interest currently between the small scale sort of modern agricultural practices that are emerging in Africa, across Africa, with the multinational companies. So what is happening currently is that some of this knowledge, traditional knowledge, are not being utilized, right? So there is a need for us to capture this knowledge to make sure that it integrated into some of the scientific modern agricultural practices that we're going to do. And this platform will create that space for that. Then it's also be useful for policy and research communities. This is also important, particularly we that are working in the the digital sort of agricultural digital platform spaces, as well as other agricultural researchers. They can also capture this knowledge, and in particular, also the policymakers can also use it to make informed decisions, or the sort of the limited resource allocations that they have, also in terms of improving food sufficiency. Importantly, really, what we're also focusing on is the idea of learning for young generations. Right. So if in the long run, this knowledge is not being captured, there's a tendency of it disappearing, and the young generation will not be aware of that. And that will have significant impact on future food sort of sustainability. So the plan is to use this platform also as a teaching tool where teachers can actually use it to teach young people about some of the traditional practices and histories that shape agricultural practices, not only in the countries that we're currently doing the research, which is Sierra Leone, but also across Africa. Because the idea is that in the long run, the full system, we create a space where farmers can continually sort of update or upload their contents so that other farmers or other people can also benefit from it. And also critical aspect is promoting gender equality and inclusive agricultural development. Across Africa, particularly in the indigenous or smallholder farming, almost I could say majority, around 80% of women are women, or 70% are women that are working, but their knowledge of the voices have not been recognized in this sort of modern agricultural practices that we have. So having a system where their voices have been kind of amplified and heard can actually help promote gender equality in agricultural productivity. If Africa is talking about food sustainability, it has to emerge from women, from the women perspective. So this is really the thinking around that. And finally, we're talking about the gap between indigenous and scientific knowledge of sort of promoting a resilient food system. Right, so here again, like I said, we try to link that sort of knowledge. So that is all, Tom. Did I finish within the time?
Yep, well done.
Great.
Yeah, that was great. Thank you, Stephen. We've got a couple of minutes if anybody has any questions immediately for Stephen.
Yes.
Please put your hand up or just speak. I don't see any hands up, but that may be because I'm not looking in the right place. I can't see any. Okay, we can come back to questions at the end. So if anybody does have questions for Stephen, just save them for the moment or write them into the chat, and we'll pick them up at the end of the session. The next speaker is going back to civil and environmental engineering. We have Abi Kabedi, who's going to talk about sustainability implications from cross-sectoral interactions and potential synergies and trade-offs. So over to you, Abi.
Thank you very much, Trevor. Hello, good afternoon, everyone. I'll try and share my screen just for a moment. Okay, hopefully my slides are up.
Yeah.
Okay, excellent. Thanks, Trevor. Good afternoon, everyone. Again, my name is Abi Kabedi. As Trevor mentioned, I'm based in the Civil and Environmental Engineering Department. I'm a lecturer in flood and coastal engineering. In the spirit of this interdisciplinary nature of today's agenda, I thought I'll share a recent work we did looking at the interactions, cross-sectoral interactions, and what that means for sustainable achieving the SDGs. Slightly mouthful title, but we use a European integrated assessment model to explore how does different sectors interact, but also how does climate and other socioeconomic drivers influence these interactions, and what would be the potential synergies and trade-offs. And that's important because often this is, as I said, this is a work which published recently. If anyone is interested, the paper can be found on our website. I'll come back to this point in a moment, but as I mentioned, these sectors interact, but traditionally they are governed or managed by individual departments or administrations, but looking at specifically individual sectors in silos. But in fact, they undergo different types of interactions, specifically how each individual sectors are affected by, as I mentioned, climate change. There are a couple of examples there that highlight that interaction. For example, there is a common thread across all these sectors, a competition for land between different sectors. And that means a policy that's made within an individual sector will have an implication to other sector. The same with competition for water, and also there are indirect impacts how individual sectors respond to exogenous or endogenous drivers that will have an implication for other sectors. So the work I'm trying to I'll present today is a work we did with colleagues. It's a large European project that developed an integrated assessment model looking at these interactions and feedback between sectors. The slide you see there is a simplified version of the modeling framework that was used to capture these interactions. You'll see there are individual models, around 10 of them, which are deliberately developed independently, but then integrated by capturing the known or potentially possible link between the different sectors. A typical example, if I look at my area, is also in flooding. If we look at the flooding model, which I was part of the team that co-developed the flooding module that went into this integrated assessment platform that you'll see at the top left corner there. You have directly affected by hydrology has a role, how flood happens and how communities or economic assets are affected. It's partly driven by how urbanization changes. For example, the change in artificial surfaces, be it through residential development or non-residential areas that facilitates or decreases infiltration, which indirectly increases potential for flooding. The other is a direct increase in socioeconomic factors like population, which has a role in especially population or infrastructures that are located in floodplains, which affects the potential risk to flooding. But this flood risk also has another, the way we captured as an example I'm trying to illustrate here is flooding has a direct impact on agriculture. For example, if land is flooded more frequently, for example, in coastal areas, agricultural land flooded more frequently, let's say once a year, becomes less productive, at least for the kind of agriculture used that mainly relies on fresh water. For example, if the land is exposed to salt water, that's one example. But also these areas, low-lying areas that are at risk of flooding, there are also places where we have these natural ecosystems like coastal habitats, which play a great deal in flood protection. But they also have a consequence if they will result in an impact on biodiversity if these areas are to be lost due to sea level rise, for example. So that's one example. This is a simplified version, obviously, but it illustrates the point I was mentioning at the start. So in this work, we conceptualized this problem as what we coined as the food, water, land ecosystems nexus. And we tried to look various drivers, exogenous drivers. You'll see there 6 of them at a higher level category or a team of drivers representing different components of, for example, climate. As we said, as I mentioned, sea level rise is one of them, or change in precipitation is one of them, another. Technological change. If I go to the next slide, probably that gives a better representation of what I'm trying to say here. If We looked at, I'm not sure if you can read slightly smaller text, but you'll see that under each category, we looked at different drivers that have a direct implication for a particular sector, which then transferred through that nexus interaction I mentioned earlier to other sectors, or directly influencing that particular sector. So we tried to capture this both direct, indirect, and potentially combined effects of these exogenous drivers to the system we were looking at. In our case, the food, water, land ecosystem nexus. We selected in consultation with stakeholders the reliability of the model replicating historically observed trends of these particular parameters. We focused on 7 indicators to represent this nexus system. And we looked at how these 25 of them, these various drivers influence the 7 indicators, the nexus indicators, to have an idea how overall the potential impact of climate change and other socioeconomic drivers affect our systems. This is a simplified version of the methodology we used. It combines 3 different sub routines, for if you like. The first one was simply looking at a sensitivity analysis. How does the system respond? So when I say the system again, as it was represented by those 7 indicators I mentioned, how does that system respond to how sensitive the system is to those individual drivers? We specifically looked at one driver at a time so that it will help us allow to identify the governing parameters that have a greater influence on the nexus system than others. And then we used that approach as almost a screening to identify those important drivers, where then we looked into a much more representative multi-driver analysis in the second part as shown in the blue there. Then, of course, realistically, those combinations of the drivers identified, some of them may not have a physical meaning. For example, an extreme precipitation under a very warm temperature combination may not be likely, let's say. So we used this plausibility analysis. We applied this plausibility analysis to identify the scenarios that are directly relevant to the potential changes that will observe for the system. Okay, so the first analysis, apologies again, maybe if you are able to see, but if you focus on slightly the more bold areas where it highlights, as I was saying earlier, the most sensitive, the drivers that have most impact on the individual indicators. You'll see the column there is the 7 indicators I mentioned for each sector. And the rows here shows the list of individual drivers who have identified, and applying that one driver at a time sensitivity analysis, we have highlighted those sectors, those drivers that have most impact on the entire system. Specifically, we use this, what we call the strong and indirect, strong and nonlinear effect on the system at a European scale, more than one sector as a screening mechanism. And we applied, then we focused on we identified, as I mentioned, 4 climate temperature, winter and summer precipitation, CO2 concentration, and socioeconomic. So 4 socioeconomic drivers: population, GDP, and change in agricultural yield, and food imports. So those are the main drivers that were identified to have the most impact on the 7 indicators I mentioned. Then we used the scenario combinations of these drivers, 8 drivers, to explore the potential, the uncertainty space, to understand how the system, those 7 indicators, respond to. And maybe just a quick, I'm slightly running out of time, so a quick indication of what that looked like. you'll see the plots illustrate area aggregated summary of the results under their ensemble mean summary as shown in the box, but also the uncertainty range as shown on the bars. But also we looked at obviously this kind of aggregated analysis hides the potential variability we might see, especially we also looked at the outputs, especially 10-minute by 10-minute grid for Europe. And you'll notice that on top right, representing a response of the few nexus to climate change, climate drivers, the 4 climate drivers, the scenarios that are driven from those 4 drivers. And the bottom left is a special response to the socioeconomic scenarios. Maybe the slightly useful, simpler way to understand how these results can be synthesized is this table here. We looked at which one, just looking at the aggregated values, whether climate change or socioeconomic drivers are important, which one is more important and for which sector. So those red signs, red texts and red shaded cells illustrate those that are those sectors affected mainly by climate, and the blue ones for socioeconomic. There is no surprise there. Food production mainly, although climate has a role, but mainly for Europe in terms of the scenarios we explored, is mainly driven by socioeconomic factors, specifically the population increase, which is directly related to consumption, and also potentially a change in food import from elsewhere. But flooding, the same, driven by socioeconomic factors, population, people located in floodplain areas. But the other factors, the other parameters are mainly affected by climate change. I'll sort of mention this. This is my last slide, a concluding thought. Basically, although traditionally these sectors are, as I started with, managed in silos, understanding these kind of interactions is very useful to devise appropriate adaptation responses that potentially help us minimize conflicts, trade-offs, and maximize synergies between different sectors. Thank you very much. Any question, I'm happy to take.
Great, thanks very much, Abby. Yeah, if anybody does have any immediate questions, we've got a couple of minutes, as always. Looking to see if there are any. Okay, then we'll save any questions for the end of it. It's interesting, we've heard quite a lot of people today talk about the complexity of the factors involved, but I think yours is probably the first time we've seen somebody try to do that in a more structured, formal way and actually analyze those different factors, how they trade off. And I guess to turn that into a question, I mean, the data requirements to do the sort of analysis that you've done, I mean, how demanding are those data requirements?
Yes, that's the major question, Trevor. You're right. Maybe for the sake of time, I didn't go in more detail about how the integrated assessment model was developed. We used what's called this meta modeling approach, basically using much advanced and highly used complex sectoral models. But they were simplified to represent the process, but conscious with the runtime we needed. So the baseline data, most of the data we used at the European level came from those sectoral models that were already used. For example, the water sector was based on the water meta model was based on water gap model, which is a very widely used model, a highly established model. But the complex processes were used using meta modeling approach. So we had the benefit of using those baseline data from those original models. But for some sectors, there was the need to to develop these sectoral models from scratch. So that was a challenge in establishing those databases. But it was, as I mentioned, it was a large consortium project, and there was luckily a resource considering that partly we had access to national and regional data sets that were not otherwise available. But also, as I mentioned, those existing data sets from existing models. But that was a challenge in the beginning, and the model we used was in the earlier version, but it's still a live exercise, and it's been revised, and recently it has been updated, for example, using the latest IPCC scenarios. So it's an ongoing exercise, and maybe I didn't go through the slides earlier, but you have noticed that it focuses, it's only on land and water-based sectors we looked at, but obviously when we look at these kind of complex systems, and especially looking at climate change, specifically energy, health, and other sectors are equally important as well, and there is effort now to integrate, to add those, to broaden basically the Nexus framework to include those sectors as well.
Yeah. Okay, no, that's really helpful. Thank you. Okay, we'll move on to the final speaker this afternoon. Mary Richards is going to talk to us about the complex dynamics of sustainable knowledge exchange. So over to you, Mary. If you're saying something we can't hear you, see your slides.
Sorry about that.
That's better.
Thank you very much, and thanks to everyone in the online audience for this opportunity. I feel a bit of an imposter in this context. We've heard a lot from engineering and scientists, and I'm not coming from that perspective. I'm coming from more, I suppose, social science or humanities background. But I guess indeed my presentation is less I suppose on research, but a reflection, or what I might like to call a series of scenes on and based on some work in progress that cuts across a couple of projects that I've been involved with, one of which I lead. And today I'm using this opportunity to highlight some of the inevitable challenges of the work from an ethical perspective, and to challenge Brunel perhaps to think more holistically and long term about our partnerships, particularly our partnerships in low and middle income countries, like in this instance, Zambia, where the two projects I'll be referring to here are based. And one of the points of linking the two projects that I and the ESCI, that's Evaluating Student Knowledge Exchange team, are attempting to do is to improve the continuity of our projects to build momentum and trust between all the constituents of the project. So the overall aim basically is to weave together a number of discrete stakeholder interests and priorities into a genuinely meaningful exchange. So an exchange of knowledge in the broader sense of the word, but also an exchange of very different contexts. And now I'm going to switch my slides. So here's some of the community members we were working with. So I'm going to start with these scenes. Scene one. He stands up amongst his seated peers, a paper in hand. He's about to read a list of questions for us, his virtual audience, thousands of miles away. I'm visible to him as a small head in a box on the Zoom screen. I float there alongside the rest of our team located in various parts of Africa, the UK, and Canada. Today is the final day of a virtual co-design workshop led by Dr. Alwyn Martin and a team of predominantly, but not exclusively, engineering academics. We're here working virtually with our existing partners and the community members of the rural and remote located refugee and resettlement site of Muyukwa in the western province of Zambia. Community members and agricultural facilitators have been working on site on a range of practical projects to respond to the challenges posed by a lack of running water and food insecurity. Food insecurity that persists and indeed has increased as a result of climate change that contributes to more frequent and severe droughts in this region, as well as devastating floods that, alongside destroying crops, contributed to another major outbreak of cholera between October 2017 and June 2018. Regardless of these realities, members of the community have these past 3 days built, adapted, and have now demonstrated their co-created designs to the floating heads who nod and smile, and then finally applaud the ingenuity of the assemblage community group, who the virtual team can see in fragments through the multiple handheld devices that link us to them. The virtual team are broadly pleased at being able to make anything happen in the face of what seems to be endless logistical, technological, and human challenges associated with carrying out workshop activities remotely. But this man stands before us. He's patiently engaged with the workshop activities, and now it's his turn to speak and ask questions, not about the technologies we've been experimenting with, but about something more fundamental. The first of these questions is quickly addressed, but for the second, there's hesitation, there's uncertainty from the team once the facilitator translates for us. He's essentially asking us, what's in it for you? It's at once a simple question, but at the same time, one that generates a multitude of mixed and difficult thoughts and emotions that the remote team have been attempting to grapple with throughout this process. How are we doing it? How do we ethically navigate the deep underlying power dynamics that exist here as a microcosmic representation of the larger global and systemic injustices that persist and are perhaps perpetuated by our very actions? A UK-controlled project to go to co-design, to share knowledge, and attempt at some form of reciprocity despite the barriers of language, power, and physical distance, to try to develop what we hope will provide some tools to more effectively respond to, on a small scale, some of the most immediate health and livelihood challenges that this community faces, without the luxuries of complex technology, finance, or investment, without constraints. Scene 2. Muyukwa is a refugee and resettlement community that's existed for over 50 years. Many of the families have grown-up children who have never set foot in Angola, where many of the resettlers fled as refugees in various ways of conflict-induced flight over the decades, pointing to the much-debated reality that in a large number of scenarios, refugees never return to the country they or their parents fled from, and that integration through things like the right to work and citizenship, or in the case of Muyukwa, the allocation of land to cultivate crops, are important legal and policy debates to ensure that refugees have the opportunity to flourish rather than languish in camps for indefinite periods of time. Well, Dr. Martin's Z-Lab co-design workshop and the parallel knowledge exchange project ESCI is not focused specifically on addressing these questions. It's an important dimension of the context given the predicted inevitable large-scale increase in climate-induced human migration. Scene 3. The ESCI project attempts to work across sectors and integrate stakeholders with varying levels of knowledge, education, and expertise. This includes UK and Zambian students, UK and Zambian researchers at the University of Zambia and Copperbelt University, United Nations actors, specifically UNDP, the Zambian government's Department of Resettlement, and the local community members themselves. The structure of the Knowledge Exchange project, which originally was to be an immersive international exchange of students between Zambia and the UK, has been modified to connect students, researchers, and community members virtually, with students enacting their own form of participatory action research, allowing us all to consider the role each of us plays in making sense of our reality and the role we have to play in the overall mission of expanding knowledge, responding to climate change, and increasing our understanding of each other as we address shared questions of food insecurity in this location, Muyukwa, and also in the UK. In Zambia, the prototypes developed through the ZLab project will be scaled up through the participation of Zambian students and the University of Zambia researchers who are planning to travel to Muyukwa in late November, December this year, and sharing their observations and hands-on learning with UK students and researchers. In this way, a range of site-specific solutions derived from locally sourced materials will be scaled up, but in ways that allow community members to retain ownership, as ultimately they will be responsible for the ongoing implementation and maintenance of whatever technologies prove to be of most interest and use to the community members, whether that's water harvesting for use on crops, vertical gardening to reduce water use and improve micronutrient availability, or packaging to improve the storage and shelf life of produce. This, it is hoped, is a project design best able to achieve practical and sustainable solutions to challenges of food security and by extension, health and well-being. Scene 4, the brief, the final scene. The ESCU project has, like so much else, been stalled by the global pandemic. This period of hiatus has, however, allowed us to usefully strategize and consider the links between, and importantly, for me at least, in terms of returning to the man's question, the legacy of associated projects that various team members are leading in both Zambia and in the African continent. How will Brunel commit itself? What more should we do? It is surely our responsibility as people with privilege and as academics in the global north to leverage whatever institutional weight we can to continue to focus resource, education, and expertise into collaborative partnerships like this one, but to do so in ways that work much harder at handing over the reins of power to allow such communities to play a much larger role in directing their own futures. I'm going to stop there. Thank you for listening.
Thanks very much, Mary. Interesting questions. Interesting questions there for people to think about. Would any, right, things are jumping around. We have finished a few minutes early, so if there are any questions for any of the speakers in this final session, or indeed any more general questions, a bit like that general question Mary posed for us all at the end there. If there's anything like that, anybody would like to pick up or say before we finish off? And just give people a chance to unmute if they are going to try to say something. Okay, right, maybe not. No, thanks very much everyone for attending today, and those of you who've been here for all 5 hours. It is surprisingly hard work being on Zoom for 5 hours and having to maintain your concentration, and so well done for doing that. We've actually had a really diverse range of talks, predominantly, I suppose, from science, engineering, but also some interesting and provocations really from other parts of the university. I think as a subject area, it is clear that there really are no areas that are untouched by climate change, by environmental sustainability, by everything ranging from our own very local practice on campus to how we conduct our research, to how we conduct some of our university business, and to how we try to use our education and research to make the world a better place. And so what we've had today are a range of contributions, some technical, some more policy oriented, some more political in tone, that touch on different parts of the overall issue of climate change and sustainability. There is always a challenge with big issue like this that you can become overwhelmed by it. And one of the advantages of having this symposium, I hope, is that it's shown people across the university how there are other people who they may not have thought of as having interest in this area, making contributions, doing thinking, And some of that thinking, hopefully, will be joined up between some of the different disciplines, the different areas of research. Just as a sort of aside, I'm sort of almost surprised by how many contributions we've had from mechanical and aerospace engineering. Don't necessarily think of mechanical engineering as somewhere that you would have a lot of focus about environment and sustainability. But clearly from the talks we've had, that there are a lot of concerns there to do with supply chains and production methods and recycling and so on. Lots of really interesting ideas from across the university, and hopefully today's sessions will have promoted some thinking amongst us all and will lead to people getting in touch with people elsewhere in Brunel and having some discussions that they wouldn't otherwise have had. We will be undertaking all sorts of other activities across campus in the next few weeks as COP26 approaches. And as some of you will have heard earlier in response to the question of Mariana, at senior level in the university, there is active discussion amongst executive board at the moment around how we position ourselves in terms of ongoing responses to the climate crisis. And I put in the chat earlier a statement from Universities UK that has just come out in the last day or so around Universities UK response. And Tom has also helpfully linked to some new web pages we've got around our engagement with the Sustainable Development Goals. So rest assured there's plenty going on, and at sort of institutional level to hopefully complement and go alongside all of the excellent research that we've heard about in the course of today. Thank you all again very much for attending, and hope to run into you all in person, hopefully before too long.